Oh, good morning, Evelyn. Good morning, guys.
Good morning.
Good morning.
How are you guys doing?
Oh,
Tired.
Me
yeah.
too. 2 o'clock this morning, I went to bed.
Oh my.
Yeah, I had some stuff to do, so yeah, but
Mm-hmm.
yeah.
Mm,
I
nice.
wish
It's
the
already
math lesson was
summer.
over.
I just washed my hair.
Oh,
Uh-huh.
okay.
Yeah,
Yeah.
so it's kind of dry now. So I shrink.
Yes.
Yeah, tired, man.
Yeah, me too. I'm looking forward for the weekend.
Yeah. Yeah, I have a Mother's Day brunch this weekend. My weekend is always busy.
Oh, that's nice.
Yeah, Mother's Day brunch. So we have it
Oh
started.
yeah. Oh, thank God. I'm looking forward for the Victoria Day. We have one long weekend, right?
Oh, yes. That's me, what, 20 something?
Exactly. Let me see.
Oh, please let it come fast.
When is the Victoria Day weekend? It's not here.
I think it's in the like 21st or somewhere there. Let me check.
Mm.
I think it's on the 17th, if I'm not wrong.
Oh, the 17th?
17?
Yeah, I
Isn't it?
remember it was like 17, 18, 19, 20 was the long weekend because we were planning on going away
Oh,
for a bit. I remember that. It was
Oh,
like a Friday, Saturday, Sunday, all the way till Monday, if I'm not wrong.
it's 20.
yeah, I
20?
thought I
Oh,
thought it
okay,
was in
okay.
the 20 something.
Victoria
Yeah.
Day is 20.
Yeah.
Oh, thank God.
Still far though, but yeah.
Yeah, looking forward to that.
Yeah.
Any plans, Evelyn?
Um, none so far, but we'll probably go somewhere.
Good for you. Yeah.
Somewhere in Ontario.
Yeah. Shabana have a plan, I can see. I can tell.
Yes.
Always have plans. I
Where
need
you
We
plan?
yeah, actually there is also a family day for the military family on the
Oh,
25th.
Oh,
So we're
nice.
going to Pitawawa.
oh, very
Very
nice.
good. Yeah, very
And you
good.
know what? Yeah, our son says that Dad, you can practice shooting.
Oh, you
I
can
Uh,
said,
do that.
This is your chance.
You can
yeah.
do that. My son does it every time he goes to Florida.
Yeah.
Yeah.
And I
Yeah,
said, no,
they go
I'm
to
too scared.
they
I'm
go
too
to the
scared to
range.
do
No,
it.
Yeah.
you have supervisor there, but they go to the range. I don't like.
Yes, yes.
Yeah, they
They
go to
go
the
to
range.
the range. And I said, okay, this is your chance, Papa, for my husband.
God, no, I'm afraid of even looking at a gun.
Me too.
Yeah, I'm
Me
afraid of
too.
that.
Yeah.
How is the maths going? How is the
Oh, I did not even look at it.
I know.
I did not
It's
I
not
even
look
fun
at
at all.
some, but it's the ones that you can easily do, like the minus, the plus, the division, whatever. I'm like,
Yes, yes. Hopefully, I'll be able to do that this weekend.
yeah, that's what I'm
Hopefully.
thinking
I
too,
just feel
right?
like once we
Me
sit
too.
down and like do a few practices, just I didn't get the time at all to do like a
Exactly.
few different questions or go online and search for my
Yeah.
own, you know. Once I
Yeah,
did that, I understand it. But honestly, it's just been such a hectic week.
week, yeah.
Yes.
Yeah.
Yeah, yesterday I
That's
had to
true.
run out for an appointment.
Because
It
once
The trick
you got the trick, you got
mhm.
Yeah,
the
and you do
formula,
like
gonna
maybe
be
20 something questions. It can be really quick too. But if you don't do them, then you're just like, oh my God, like now I'm stuck again, you know?
yeah.
You sound like somebody who know maths.
For me, trust me,
Right.
I do not know maths at all.
I used to love it when I
Me
was in high
too.
school.
Me too. Me
No, I
too.
never liked maths. It was just like I did law only because I was like, okay, you know what? It won't have maths. And then I was just like, why did I even get myself into this?
Oh, you did law?
Yeah, in Singapore I did law.
Oh, that's good.
Really?
Yeah, we were,
Wow.
me and my husband both, we did law in Singapore.
Oh, that's good. That's good.
Oh. So what
That's
are
good.
you doing in healthcare in
I
medical?
always wanted to be in healthcare, Evelyn, to be honest, but law was just
Yes.
something that I think I jumped into, and I was like young and I jumped into it without actually thinking if I wanted to pursue or not. And then
Yes.
once I came over here, they were just like, oh, you have to do the bar again and everything. And I really didn't want to go through all of that again, you know? So,
Okay.
but I have worked as like a solicitor for a bit and all that, but it was just not in my scope of interest.
Yeah.
Especially like after the kiddo, I was just like, you know what? It's hard to just sit down
Yeah.
the
Yeah.
whole night and work on
True.
cases, create
Yeah.
files. It wasn't
What
something that I
about,
had time for.
but what about paralegal?
Yeah, so I tried over here as a paralegal as well for a bit, but it wasn't
Okay.
something that I wanted to get into. Like my friend, my husband's cousin, actually, she's a paralegal here, and I have a friend who's a lawyer, immigration lawyer as well. But it's just, I mean, I see them and how hectic it is for them. I'm like, you know what, this is
Yeah.
not my scope anymore.
Yeah. Yeah.
Mm-hmm.
That's like me with accounting. It's like, oh my gosh, enough is enough. Like
I know.
I
Even the
didn't.
accounting is really good over here. You make like decent amount of money.
Oh yes, but
Yes,
the
of
stress,
course.
the stress.
I
I
know.
don't know.
As like my point, like with a kid, I just felt like I couldn't do something that was going to consume my time even after work hours, you know? Like I
Yeah.
can do a 9 to 5 or a 9 to 4 or whatever. But then if I have to come home and work on something just because of work, I can't do that.
Yeah, I stopped it
Yeah.
years ago. I
It's
stopped
not.
that.
It's not easy. With a family,
Yeah.
it's not easy. You have
It's
to
not
juggle
easy. And because
your.
over here you have to do everything by yourself. In Singapore, you had the
Everything
option to
That's
like have
true.
somebody who's there
to
and
help
helping you throughout
you.
the
Yeah,
house, you know?
yeah.
So, but over here you
Therapy.
don't have that option. So you have to look into pick and drops and like lunches and dinners and cleanups and this and everything. So
Mm-hmm.
it wasn't working for me.
Yeah, sometimes I need to call somebody in to clean for me.
Yeah, we do the same, honestly. Every 2 week once, you need someone to come in thoroughly, do everything.
Oh, that's good.
Yeah.
Yeah, I need that. I used to have this girl, but she moved to the States. She bought a business in the States.
Oh,
So
nice.
yeah, she's doing very good actually over there.
Mm.
From the
I mean,
90s.
over here, a lot of people need the extra help, and I think they do pretty well. Like even the lady that I have who comes over, she
Mhm.
tells me sometimes that she's so busy, I have to literally tell her like a week beforehand so she can like
Mm-hmm.
put me in. That means she's actually every day going and like helping out at different places. So
Yeah.
she's just like, oh, I'm more than happy. I go there for like 3-4 hours, and then I make like 120, 130. And I'm
Oh, so the price is right.
yeah,
It's
the
not
price is
bad.
not bad. It's not
Yeah.
that bad because most of the people that I did find, they were so expensive.
Hmm. Yeah.
They're charging like 35 per hour.
Hmm. Yeah.
Yeah.
That's good.
Yeah,
No,
she's nice.
actually,
She's
even
been with us for
yeah,
a while.
even for our course, our program in MLAT in hospital, it's more or less.
Yeah,
Yeah.
not even in hospital starting salary is 35. No.
Oh,
No.
really, ma'am?
No.
I
No.
no. Yeah.
No. When I have started long before I started with 23. Now they have
Oh,
raised, but it's not now probably Lifeline and other things they are giving only 23 or something like that. But
Yeah.
no.
Yeah. Just
No.
above minimum wage. Yeah.
Yeah.
yes,
Just
that's true.
yeah. So and you have to accept it, otherwise you are not going to get the job. So
Yeah,
yeah.
Exactly.
take it, get the experience, and move on.
Yeah.
Yeah,
But
Actually,
till there is a till there is a
experience.
maximum slab. It's not like the exact, but yeah, maximum slab they can till now the maximum slab when you reach after 7 years or something like that, that
salary
is
cap, ma'am.
36. That is
Yeah.
36.
Oh,
That is
you
36.
reach the ceiling, they say.
Ceiling. That is
Yes,
36
ma'am.
now. Yeah, that is the 36 now.
My friends in Life Labs right now, mom is 26, but they're what's now 16, 4, 8. So it's like 16 years of experience.
See.
Oh, wow.
15
Yeah.
to 16 years of experience. 26. Yeah, they're getting
So
26.
basically, what your Google say is not right. That's
No,
the
it's
thing.
not.
Uh-huh.
Because whenever we did the ESS code, employment success strategy, that time you have to make the students for the interview. We have to
Yes,
ask
ma'am.
different questions, whatever generally what type of questions they ask, just like the mock interview, and then that is one of the option, your salary expectation and other things. So everybody will say from the Google search, I don't blame anyone, that whatever
Mhm.
they are telling, and if you say that, you are not going to get the job. So you have to tell, okay, whatever you can offer me, and then it's negotiable. That's the thing. Yeah.
Yeah. Actually,
But
ma'am, in Indeed, our website of, for example, the Scarborough, the Shin,
mhm.
they will put the salary expectations on their website.
Some people does, some people doesn't. So it depends
Yeah.
upon, even they tell their salary expectation when we'll go in the interview. If they say even new, some maybe sometimes they bargain. But if you get in a hospital a little bit better, or even the part time or the casual, anything at the beginning,
Yes, ma'am.
accept it.
Yeah.
Accept
Asinet
it.
and
You
I are hoping that Brampton has it.
An hospital. The worst
you will
hospital, but we're going there.
We're going there, ma'am. We'll
Gonna
wait
make a
for
difference.
September. God willing.
there is a new hospital. Is there bringing?
No,
No,
ma'am.
Brampton
The
Hospital.
Brampton Hospital.
They have two. They have one
Peel,
downtown
Peel and
Brampton.
Peel and Brampton Civic. That's what you are telling, right?
Yeah, yeah.
The Civic
And
Hospital. Yeah.
So Brampton Civic is
Huntington
Brampton
opening.
also.
Civic.
Brampton Civic is opening now.
No, Brampton Civic is open, but they're opening up they're starting to build the new old Peel Memorial
Oh.
Hospital. 'Cause
Yeah,
right now it's just an urgent care and like day patients, so dialysis and stuff like that.
yeah, that's I know.
Uh-huh.
Yeah,
Yeah, and then they're going to bring it into a big hospital because Brampton Civic is garbage,
Oh.
and
exactly, exactly.
yeah, and everybody goes outside of Brampton for help.
Oh my
Yep.
gosh.
Yeah, we have in Credit Valley Hospital. Our 70% patient is from the Brampton.
Yep,
Yeah, they're running.
yep, running like the wind, Asenath. I wouldn't go there
They're
for a
running.
Band-Aid.
It's true.
They'd
It's
get
So we
like
can go there. We can go there and make a difference, Cara.
yeah.
exactly.
Go in and help the surgeons who remove the wrong limbs of people.
Oh,
Oh my god.
They did. They took the wrong leg off of a man and then they had to wake him up
Oh
and take his
really?
good leg. Yep.
Oh my
That's
goodness.
legal.
Yep. That's a huge malpractice suit. But then they only
That's
pick
right.
3 out of all of Canada malpractice suits, and then only one of them will be awarded money.
mhm.
Yeah, that's what happened there.
Yep.
Yeah,
So now he gets
because
to go
before
around.
they actually they're quite they want to protect themselves before they do the procedure. You have to
Yes.
sign.
Mhm.
And then a
You
man,
have to
my
sign that you
best
are
That
friend,
is
allowed.
everywhere you have to sign. That is the
Yes,
consent.
ma'am.
That is the consent.
Yes,
You have
ma'am.
to give the consent. You are giving the
Exactly.
consent that they are going to. You are giving for the right one, but what they are doing there, who
Exactly.
knows?
and
Yeah.
you know how patient IDs are most important?
Yeah.
Yeah.
Well, they ID'd the wrong man because he had the same name as another man, and they killed him.
Oh.
Oh
Yeah,
no.
They gave him the wrong medication.
that happens
Oh.
so often.
Mm-hmm.
You'd
So
be
patient
surprised. A lot of things are
identification
not even
only.
documented, but this happens a lot. I've heard
It
a
Yeah,
lot.
happens
that's
a
why you can
lot.
understand first name, last name, date of birth, and
That's
Right.
right.
if those are same,
Exactly, ma'am.
then you are
Yes.
Card
going to
number.
the health card number.
Yep.
Patient
Profession
Exactly.
number.
ID is very important. Blood grouping, when
True.
we do for the
Yeah.
blood supply, need the blood transfusion. If there is
Yeah.
no, and for the blood transfusion, you need 3 witness to sign. But
That's
And
right.
the
everybody has to
spelling
be
too.
very responsible
That's true, ma'am.
in the spelling
Yeah.
in hospital. If there is in our tracker, if they have the same name, it comes in a different color. So if everybody is black, they comes in the red color, so we know these 2 patient has the same name. But at the same time, you have to check so many times you have the same name, same date
Yeah.
of birth, same date of birth.
That's
Yeah.
right.
That's
Exactly,
why I
ma'am.
really
And
like my name.
then date of birth, then what is the patient, and then sometimes we read the history, right? What is, then we ask them,
Yes.
you came
Yes.
for what reason? Somebody came from the flank pain, somebody came for a different reason. No, I was doing this one. I say it doesn't match. Okay.
Mm-hmm.
Then
Yes.
sometimes it's because you doesn't know the people, right? So you can know
Yeah.
the first name, last name, date of birth. That is the regular things. Then you check for what you are coming, and
Yes.
but for who is working in the outside of the lab, they have their own requisition, so you can just check the health card number too. So that's patient identification is one of the most criteria in our job.
Yes,
Yes.
ma'am.
And not
Yeah,
only us,
I
yeah,
agree.
because yeah.
Yeah, ma'am.
So who
When
doesn't?
I work in blood bank in Saudi Arabia, ma'am, the lab is under CAP and AEBB standard. So one mistake in the spelling, cancel.
Yes.
Yeah, even the spelling of the family name usually the sample is cancelled.
Yeah, there should be
Yes,
sample
ma'am.
should be cancelled. We cannot go and correct it. Even if there is
True.
any problem in anything, if the sign, lab will immediately reject it. Even we know each other, we are very good friend between lab and here. The sam is very difficult. The patient, no. We understand. Sometimes, okay, so it's very hard to, and doctor is getting upset. I said, come tell the doctor to come and take the blood. It's so difficult poke, and we cannot get the blood. Even we get the blood, but they cancel. We understand that. Sometimes we go and tell, but no.
True. Yes, ma'am.
Yeah.
That's true.
Hi.
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 You doesn't have school today?
He does. He's just gonna get dropped off soon, but he's gonna have his breakfast very quickly.
Wait, breakfast?
Mhm.
Oh, what your mom made breakfast for you?
I don't know.
Your French toast?
Yeah, French toast.
Can I come? Can I
Yeah.
come? Can I come and join it you?
Exactly.
Join us?
Yeah.
Yes.
Oh, good girl. Goodbye. Thank you.
Bye.
Say bye bye.
Bye. Okay, so how
See you
many are
guys.
here? Okay, see ya. Have a good
See
day.
ya.
Enjoy in school. Have a good study.
Thank you.
Okay.
Yeah.
Okay. So
Shabana,
not-
your son is JK or SK?
JK.
He's quite young, yeah.
Yeah.
JK.
Yeah. So I'm coming in next year. I'm coming to JK.
Aw. Yeah.
What then?
I like
Hey,
your
enjoy
t
your day.
I like your t-shirt. It's so
JK?
nice.
Oh, what? She said she
Yeah.
likes the t-shirt. Look, your t-shirt. What does your t-shirt say? That's a Harry Potter shirt.
Beautiful shirt.
Harry Potter. Says
Yeah,
Harry
you like Harry Potter? You like Harry Potter?
Mommy.
Krishna ki sibling. Who is not here till now? It looks like Alexia. Yeah, Alexia is not here. Anyway, let us see. You guys did work on your homework yesterday?
Some of it.
Some of it.
Actually, me, no, mom.
Okay.
I did the
Yeah,
easier
it's
one.
overwhelming, mom. I just want to have a brain rest
Yeah, true.
Brain
until
rest. Brain
motivate
rest.
my brain, motivate,
Oh,
and then do it hopefully on the weekend.
yeah.
Brain
I'm
rest.
praying.
That's the new
That's right,
terminology.
mom.
That's the new
True.
terminology I heard today. Brain rest.
Brain
I'm
rest.
praying. I'm praying for a week to get a week off.
Yes, yes. Because last week
I
was
need to. I need to. I need to. I need
need a
to.
week.
Oh my.
Do we get a week off?
Not before. No, not anymore because you are not in Christmas. Not before that. There is no week off.
Just the Victoria Day weekend.
That's all. You have no more week off. You guys are almost done.
Yes, ma'am.
No, I think we will have after that as well, but it's in June, if I'm not wrong.
Oh, that is no.
Yeah.
You have to do the placement. You have to do another one. ESS. ESS you didn't do. It generally does after the course. So ESS, Employment Success Strategy, and then you have to go for the placement. And before that, you are going to write our final exam, and then you are going to be ready. So who is not here till now? Alexia is absent today. Yeah, this is 921. So I can just Alexia is absent. Yes, Sabana is here today. So all others are here. Okay, good. Alexia is absent. Everybody is present. Let me do this one. This one is done. Close. Then let us go to our course. What is inbox? No. Hmm. Content. Unit 3. Unit 4. Unit 4 is reagent preparation. What? Unit 3 calculation. Equipment unit 4 introduction to care. Oh my god, too many things to do. Okay. Okay, Alexia didn't send any message, so she's absent right now. Okay. Okay, so we are going to sum up this. You already learned about the different systems and other things, the different the conversion, what to use for which one. So today we are going to this course actually this PowerPoint will deal with how to do the reagent preparation, measurements, equipments and reagents. Some probably Sign has already gone through you. I don't know whether she did or not, but we'll go through it and maybe you can tell me whether you have learned something. Then we can skip and go ahead so that we can complete it. So as I told you yesterday, what measurement system we use is called the International System of Measurement, or in short, it called the SI unit. Okay, SI units. And this is based on metric systems. Metric system uses divisions and multiples of 10 always like that, meter, kilogram, second, tens. An international system, this is mainly SI units also relate to the metric system, is based on the metric system. And what are the base units of the SI system? We already learned yesterday, meter for length or height also, they didn't write it that. Kilogram for mass or weight. Second for time, mole for amount of substance. What is the amount of substance is present in some solution or something. Ampere for the electrical current. Kelvin or Celsius for temperature. The big temperature generally use the Kelvin, Celsius also they use for the temperature, but the no Fahrenheit. And candela is the luminous intensity. So abbreviation for SI units, we already discussed, just repeating it. Meter is small m, kilogram is kg. If it is gram, it's going to be g. So medically kilogram is kg, second is s, mole is mol, is not mole, it's going to be mol. Is millimole, then one would be m here, then mole. Ampere is capital A, Kelvin is capital K, Celsius, the temperature, C capital C, but candela is abbreviated small cd. So these are the most of the, generally you doesn't need cd, you doesn't need the A, because we doesn't need that much. Only you are doing the calibration of any instrument or something. But you have to know the temperature. For Celsius is capital C, Kelvin is K, but the capital, but all other are small, meter, kg, second, mole. So this is, you have showed yesterday, everything SI units is always divided by the 10th. So mega, when is, they are going to give you the chart. So all SI units can be qualified by standard prefixes that subs to the convert values. Prefixes means 10 to the power, this 10 to the power this. Convenient forms depending on the size of the object being measured. So mega is called M, indicates 10 to the 6th power. And kilo is the 3/10 less. So kilo is abbreviated, indicates 10 to the 3rd power. Let's say 1000 3rd power. Mega is going to be 1000 and then 3 more zeros. That is the mega. Deca, abbreviated DA, indicates 10 to the 1st power. That you saw yesterday, middle one, and then you are shifting on the left. It's going to be the 10, 10, 10. So deca is 10, then hecta is 100, then kilo is 1000, and then you go more above, 3 more tens is going to be the mega. Same thing when you go to the down, first in the middle is the m or some, whatever the unit is, and then deci is only 10th negative, 10 to the power minus 1. Centi, 10 to the power minus, centi is going to be 10 to the power negative of this power, deci. Milli, abbreviated m, indicates 10 to the power negative 3rd power. So 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. So micro, abbreviated, so micro is more, 1000 less than milli. So it's going to be the 6th power, because 1, 2, 3, 4, 5, 6. Nano is going to be the 9th power. So it's going to be more diluted or more small. And then nano, then you have pico, then femto. There are a lot of, so how this is, say 10, deci 10 to the power minus 1, centi 10 to the power minus 2, milli 10 to the power minus 3, micro 10 to the power minus 6, nano, as we take 10 to the power minus 3, this is the power in minus, because these are small units. Pico 10 to the power minus 12, and femto is 10 to the power minus 5. We in research, we have to deal all the concentration. This we doesn't deal too much. This is mainly in the higher, when they do the commercial purpose, but we used to do up to the kilo or mega. But they can ask you, they can 10 to the power 15. So what is the power? 15th power. So this is the thing you have to remember. And there are a couple of signs. Milli is M, centi is C, deci is D, deca is DA, hecto is H, kilo, K, mega, the capital M, because it should not be confused with the milli. Milli is small m and mega is big M. Same thing, micro, whatever you need mainly, if you have to know micro, nano, that's all, meter, centimeter, like that. So SI unit for length is meter. 1/10 of a meter is a decimeter. Is going down 1/10 is less than 1. So 1/10 is a decimeter. 100 is a centimeter. So 100 centimeter is equal to 1 meter. 10 decimeter is equal to 1 meter. So when there is 10 decimeter, you can make 1 meter. When there is 100 centimeter, is equal to 1 meter. When is 1000 millimeter, then is equal to 1 meter. So if you say 1 millimeter means 1000 of a meter. Is that clear to everyone?
Yes.
Okay. So 1000 meters equal to, so then means 1000 meter means 1 kilometer. So meter is in middle, 1000 meter is equal to 1 kilometer. So that means 10 meters is equal to 1 decameter. 100 meters is equal to 1 hectometer. 1000 meter is equal to 1 kilometer. If we go in the upstairs, in the up side, and downside is the deci, centi, milli. So then when you go to the weight, is kilogram, is the same thing, only the units represent in the different. Kilogram is divided into thousands called gram. So 1000 gram is equal to 1 kilogram. That's it. 1000 grams is equal to 1 kilogram. And same thing, if you go down 1000, when is a milligram? This is the 1 by divided by 1000. So 1000 milligram is equal to 1 gram. The gram is also divided into 1000. And mainly we are used this mostly the milligram and gram. We doesn't use this too much kilogram. This you have to have a very clear concept. This is very easy, whether it's a meter or weight or liter or anything, is always go by the 10th division. That is the easiness for the metric system or SI system. Unit may be, when you are talking of the length or height, is going to be, you have to express it, the unit is a meter or centimeter or decimeter, whatever the fractions. And whenever is a weight, kilogram, that's the main unit to express. From the kilogram is going to divide it into different subdivisions as per the 10th, from again is 10 units. One to another is 10, is down or up. Middle one is 0, and then you are going to the minus, 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 or plus, plus, plus. The addition of 0. That is the 10th. Each step you go in the left, you are adding 10 times 10. And when what step you are going down, you are multiplying minus 10. So same thing, 1000, 1 kilogram is equal to 1000 gram. And 1 gram is equal to 1000 milligram. So if I say 1000 milligram, 1000 milligram means 1 gram, right? If I say 100 milligram is equal to how much gram?
0.1.
No, 100.
100.
What I said, sorry, just give me. Yeah, 100 milligram. 100 milligram is equal to how much gram?
0.1 gram.
1 gram, I think.
1 gram. 1 gram. 1 gram. Yeah, 1 gram. So it's going to 10 units, right? Gram to decigram is 10.
Yeah.
Okay. Okay. So SI units or volume liter is the same thing, only is called in a different unit. So liter is divided in thousands, called milliliter, millions, microliters, billions, milliliters, nanoliters, like that. So it's called the milliliters. We call the ml. We maximum use this one, ml. We also use microliter, which we use the micropipette, you know, for doing the autopipette. So we use the microliters because this is small volumes, and then there is a nanoliter, is very difficult to measure. So generally, it's in the theory we use it. We doesn't use it in practical in lab, but you have to. The most thing is milliliter and microliter. So 1 liter is equal to 1000 milliliter. That you have to know because you are measuring the big volume, right? We say 250 ml. 250 ml is equal to how much liter?
What's your question, ma'am? 50 ml?
No,
How many
250,
liters?
250 milliliter is equal to how much liter?
It's
0.25.
0.25.
0.25,
Exactly.
yeah.
Because it's going up, so you have to less. So 0.25. So you got it, how to do that. And if it is the reverse side, so you are going to, if you say 250 milliliter, sometimes they can tell you how much. 250 milliliter, how much liter it is. So you have to know, you have to divide it by 1000. So it's going to be 250. It's going down, so you have to multiply. Going down means it's getting more diluted. So liter, milliliter is difference is 1000 units. Same thing, milliliter to microliter is division of 1000 units. So 100 microliter is equal to how much milliliter? 100 microliter is equal to how much milliliter?
Sorry, ma'am. Can you repeat, please, Andrew?
100 microliter equivalent to how much milliliter?
Micro.
Is it 100,000 milliliter?
No.
Andrew.
Microliter is a unit, small volume. Micro is 1000
Equal how much millimeter?
milliliter, not millimeter, liter.
Thank you.
100 microliter is equal to how much milliliter?
0.1.
0.1. Simply, you
0.1.
have to divide by 1000 micro.
Yeah.
Okay. So now if I say 10 milliliter is equal to how much microliter?
10,000.
Yes. You are multiplying from this side because you are going down. So you have to multiply. When you are going up, you have to divide by the unit of the 10th. So here is stating from directly from micro to milli. So we are dealing with the 1000. But when I do the kilogram or meter or something, it's but depending upon the unit, you have to divide it, whether it's centimeter or decameter or decimeter or hectometer. Generally, centimeter, meter, and what is called kilometer is generally used, not the between one. Okay, so SI unit for amount of substance is mole. These you have to understand. Those are only the 10th units, the mole. Mole is defined as the quantity of the chemical equal to the present in the 0.12 kg of pure carbon. Carbon valence is 12. So that means this amount is carbon is present. So mole is the quantity of the chemical. in the purest form. Temperature, degree Celsius. This is basic unit of temperature in the SI system is Kelvin, but it may be impractical in cases because it's so huge. The Celsius scale is used most often in the clinical laboratory. You can say 37 degrees centigrade for the incubator, 21 degrees for this one, that one. So generally in clinical lab, we use the Celsius scales is centigrade. But the SI unit is Kelvin. And what is the difference? 273 degree. To convert Kelvin degrees to Celsius at 273. So that means if is we have 10 Celsius degree, 273 plus 10 is going to give you the Kelvin. To convert from degrees Celsius to Kelvin, you have to subtract. So we have 293 Kelvin. So how much is the Celsius? You have to subtract the amount. So minus 20. So
Yeah,
it's going
20.
to be 293 minus 273 is the 20.
20.
So
the yes, ma'am. The 0.15, the 0.15 will be insignificant, eh?
0.15.
Yeah,
Oh, that is
273.15.
Actual value is like that, but that
Yes,
doesn't
ma'am.
feel the temperature, right? Point something. That's why yesterday we taught 34.3 or 34.5 doesn't matter. You feel the
Okay.
34.
Yeah, that's right.
But if
Okay,
in calculation, if in the calculation in the question it comes 273.15 in the question, you have to follow exactly how much is you have to add or subtract.
Okay, ma'am. Thanks.
But in reality, you are going the decimal points, you are not feeling it. So temperature conversion, you already probably know that to convert from degrees Fahrenheit to degrees Celsius, subtract 32 from the temperature in Fahrenheit and multiply 5 nines for 5 divided by 9. That is the formula. This is garbage for telling like this. We have the formula. You guys know the formula. The basic formula is C by 5 is equal to F minus 32 by 9. So I generally remember one formula, not the different formulas. And then I just put the values. What is the need the centigrade or need the Fahrenheit? I have the centigrade, I put the centigrade there, and then I can calculate the Fahrenheit. If I know the Fahrenheit to degree change to centigrade is defined. So that is the thing. So you have to remember the formula. Instead of telling this, convert from degrees Fahrenheit to degrees Celsius, subtract, because obviously Celsius, you have to subtract because Celsius is less than the Fahrenheit. From the temperature in the Fahrenheit, and then multiply by 5 nines. So if we have the degrees, convert degrees from Fahrenheit to degrees Celsius, subtract 32, the Fahrenheit, and multiply by 5 nines. 5 nines is 5 by 9 instead of, and degrees Celsius to degrees Fahrenheit, multiply the temperature in Celsius by 1.8, which is 9 by 5. So they can also do that same thing. So you directly from Celsius to Fahrenheit, you can say for 10 degrees Celsius, so you can multiply by 1.8. So it's going to be 18 degree, right? 10 degrees Celsius, 10, 1.8. Yeah, we are converting from Celsius to Fahrenheit. So 10 degrees Celsius is equal to 1.8 times 10 is equal to 18, and then you have to add 32. So then 18 and 32 is going to be 50 degree, 50 degree Fahrenheit, 50 degree Fahrenheit. So that's we are going to calculate it. So temperature scale, compare reference points of 3 temperatures. Okay. So the boiling point of water is 202 degrees Fahrenheit. Mainly we go for Kelvin is Celsius is 100 degrees centigrade. When we lab, boiling point of water is 100 degrees centigrade. And here see, when Celsius to Kelvin, right? You are changing, you have to add 273. So easy. So it's going to be 100 degrees Celsius plus 273. That is get the Kelvin temperature. You can add 273 with the Celsius is going to give you the Kelvin temperature. But the Fahrenheit, you have to have the formula and go to, so boiling water temperatures 212. So you have to, that's why they make a standardized system that not everybody is writing different units and getting confused. Body temperature in Celsius, normal 37 degrees centigrade. In Kelvin is going to be 37 plus 273 is 310. And in Fahrenheit, it 98.6 degrees. Here we use this unit. In USA, they use this unit. So it depends upon. But generally, in the record, we use, in the clinical things, we use the Celsius here. Freezing point water is 0 degrees Celsius, which is 32 degrees Fahrenheit. 32 degrees Fahrenheit is means 0. Ice water is freezing or melting. And is same, it will be the Kelvin, 273. 0 Celsius means same, Kelvin 273. For additional comparison, 6 text table 6.4. So this is all clearer to you guys, it looks like. What are the non-SI units and reporting in SI? Non-SI units relevant to the clinical laboratory analysis include minutes, hours, and days. Because this doesn't go in the 10th division, right? It has their own timing. Minutes to hour 60, then how many hours is going to make a day? 24 hours is make a day. So it doesn't follow the 10th division's rule. That's why it's called the non-SI units, which is used in the lab. Pressure is expects in millimeters of mercury, that is mm of Hg. You know, when you read the blood pressure and other things, how you express is millimeter of mercury. And enzyme activity is international IU. Any enzyme activity we measure the activity and express as international units IU. Reporting numbers. Report both the numbers and the units by which result is measured. Like the concentration, mass, or volume, how you have measured it. If you measure the concentration, don't use the unit of mass. So you use the concentration, like the milligram per ml or gram per dl or something like that. And this is the very important part of laboratory result. Now you have already learned TC, TD, and this one I most hate because it doesn't need to be used, but they just always put it there. So anyway, just the review. Regardless of composition, most laboratory supplies must meet certain tolerance of accuracy. Vessels holding and transferring liquid are designed either to contain and to deliver a specified volume. Contain and deliver a specified volume. Most lab works can be divided into two main categories according to use. Containers like beakers, test tube, Erlenmehl flask, and reagent bottles. And we have the volumetric ware, the automatic manual pipettes, volumetric flask, graduated cylinder, and burettes. So there are two categories. Like the beakers, these are contained, and volumetric ware, like the volumetric flask, graduated cylinders, those are the volumetric flasks are very specific measurement. So refer to your lab or PowerPoint for LSP unit for a refresher. So you can go through that. This is important. So that's why they told refer to your lab or PowerPoint from LLSP week 1 unit 2 for a refresher. So these questions is going to come. So go to there and just refresh your about the what is TC, TD, and what are the different types of glassware we used for this one. So this may come in question. Care and cleaning, that we also done, but till just to refresh, must use clean, unbroken labware to ensure accurate results. To ensure pure reagents, all labwares must be free from contaminants from previous use that can affect the new solution, right? You have to clean properly following all the cleaning criteria which we learned in the LLSP model. Store protected from dust and breakage. So you have to keep it like how we keep it there. That is, we are just training, but generally we have to cover all the flask or beaker or cylinders so that no dust or nothing can go inside. And discard glassware with chips and cracks. If there is any breakage or anything, you are not going to use it. Balance. We already know there are different types of balances in the lab. So again, you can go to the unit 12 for the pressure in the lab. The two most common balances used are analytical balance and top loading balance. Analytical balance use small quantities and it has more great accuracy and up to 4 decimal places. These are important. Most commonly used balances are analytical balance and tabulating balance. If the question comes, most common balance used in the labs with 4 decimal place, you have to choose the analytical balance. Because it can measure up to the 4 decimal places, means after the decimal. So it can weigh 1.003. Up to this, it gives you the accuracy. It's gram or milligram or anything. It can give you the accuracy up to the 4 decimal places. So you can use the very small quantities in great accuracy. What is the most common balance we used with the great accuracy? Choice, analytical balance, top loading balance, others. So you have to use the analytical balance. So read the question to give the answer. And tabulating balance is the another name is precision balance. Is less accurate, 3 decimal places or less. It may go 3 decimal places or but faster than analytical. We generally use this one where that is not needed to be accurate. So you are using 5 gram. So if it is 5 gram, 5.1, it doesn't matter. Even is going to give you the 5, but even it's 5.002 or 5.003, it doesn't matter. So 5 gram is a huge amount. But when you are using 2 milligram, you cannot use the top loading balance because there are a lot of interference also. So you have to use the analytical balance, which is covered from all sides, and it can give you the high accuracy up to the 4 decimal points. How to use a balance? You already know. Read the balance instructions prior to using. Balance should be clean of debris. Can use a brush to clean. If there is something left over, somebody leave some chemicals or something, always check because there is something there is going to interfere, especially when you are doing the analytical balance. It is going to give you the wrong results. Balance should be clean of debris. Can use a brush to clean. Balance should be on a level surface. Always. You have to check the level. Never place a sample directly on the balance. Do we know you have to use a weighing board or sheet or a dedicated labeled container? So when you are using this top loading balance, you can use directly a container like the because it's a big amount. But when you are the analytical balance, you cannot use any container. So you have to use either weighing board or weighing paper. If the balance has a draft shield analytical, close the doors before taking the measurement. Okay. This page not found. Nice. So you can measure one or two ways. Place the empty labeled weighing board on the scale that we already learned and press the button, TR button, to go back to 0 and directly weigh the chemicals. So you press the weighing board on the top of the balance, then press the TR button or the 0 button. So that means the weighing board including is going to make it 0. So you can add exactly your amount you needed. You add the amount exactly you needed, and then you can complete your weighing. But another way is that you can make a 0, then you can put the weighing board and see the weight of the weighing board. So you can write it down in your book how much is your weighing board, and then you put your sample or chemicals or anything, and then you have to add how much is the weighing board plus your, say for example, the weighing board is weighing 0.1. You have to measure 1 gram. So if you put the 0, then you can directly measure your chemicals to 1 gram. But if you just press the 0 first, then put the weighing board, and the weighing board is showing you 0.1 weight. So you have to weigh 1 gram. So how much you are going to weigh this time? 1.1 gram. Did everybody understand that? Is clear or not?
It's clear, ma'am.
Okay. That's why he said, number 2, place the empty labeled weight board or container on the scale, record the weight. Weigh out chemical and subtract the weight of the container. Okay? So which do you think easiest way? Obviously, making the 0. Best practice is to write the chemical name and volume you want to measure on the edge of the weighing board or the container if you want to do like this, so that it's going to be easy for you to remember. Centrifuge. You are already doing the centrifuge. You guys make a big mistake, not balancing. You should have enough experiences now. Centrifugation, I can skip it. The centrifugation is used for separation of solid material from a liquid material. Solid, semi-solid, anything. Applying rapid rotation or spinning. Important to balance all loads. Balance all loads, not even what is called rely on anyone. You have to your sample, you have to balance your sample with your opposite side. Whether they have left this blood, that blood, no. You have to balance your sample with your balancer. It was almost going to be a big accident on the first day. Who were in the first day exam, you guys know. Important to balance all loads to ensure proper function. Avoid aerosols by only spinning cap tubes and use bucket lids. So you are not using the bucket one, so you are using only the fixed one probably. So bucket lids. So you have to make sure your tube is capped properly, and you are going to put all the bucket lids in the individual bucket in the centrifuge. And if there is any breakage or anything, you have to stop the centrifuge, and you cannot open it 30 minutes before because aerosols has to settle down. If now they are coming. If the tube breakage occurs, turn off centrifuge immediately. Leave the lid closed for 30 minutes to reduce risk of aerosols. Notify co-workers because so that they cannot come, take out the tube and start their spinning their samples. You have to notify the co-workers or write a note that the centrifuge has a broken things. Okay, need to take care. Notify co-workers, place a sign on the centrifuge. When centrifuge, remove bucket with broken tubes to a biological safety cabinet. How you are going to take out all the tubes? By hand, right?
No.
With what?
By
With this clip
With the
yes, the clip,
and
yes.
forceps.
Mm.
Tube holder.
How you are going to take out all the tubes from the broken tubes or anything from the centrifuge?
With
use a
With
tweezer.
forceps, with forceps,
Forceps,
Tweezer.
with
or
forceps.
yeah.
So you are going to take out all the and then immediately transfer to the biological safety cabinet because you doesn't know what is there, right? So
Yes.
take that one. You are going to open the, obviously you have to wear the proper PPE with the shield and everything, eye shield, face shield, whatever, and then mask, everything, and then you have to transfer to the biological safety cabinet. Document name, accession number, and broken tube. Ask another MLP to help with this. Remove any debris because the sample is lost. So you have to keep track, right? You have to write in the document name, the accession number of the broken tube to make sure whose sample is lost. Remove any debris and dispose of it in a biohazard waste receptacle. If there is a glass, it needs to be removed obviously with the forceps and disposed of in the sub containers. Decontaminated affected bucket and lid. Centrifuge interior safety cups and buckets and rotors. As per the cleaning guidelines, the metal surface is to be cleaned with what?
2% glutaraldehyde, ma'am.
And the plastics and other things, the rubber areas is going to be clean with?
And bleach.
Bleach.
But can
What
be also
percentage?
70%.
What
1%.
percentage?
1%.
1% bleach.
1% of bleach.
Okay. Okay. Notify co-workers, centrifuges get to. Then once you're done, everything is clean, then you can take out the sign and tell them that it's ready for use. Notify ordering physician's blood needs to be recollected. That's you have to do because it have the sample 1 or 2 or 3 sample has been destroyed. You have to notify the ordering physician that blood needs to be recollected. Autoclave, any reagent required to be sterile, they will have to go through an autoclave cycle. You have autoclave details. We have learned what is the indicator we have to use to make sure it has been properly sterilized.
Biological.
Biological.
indicator.
Okay, you guys got it now after doing so many
Yes, ma'am.
mistakes. Biological indicators. The complete sterilization, you have to remember, you have to use the biological indicator. Where you are going to put it, the biological indicator? Inside the pack? Where you have
Yes.
to put the biological
Yes.
indicators?
In
Inside the
between.
package? Inside
Yes,
the
Yes.
ma'am.
package?
Yes,
Inside the
Yes, ma'am.
package?
Yes,
Yes.
ma'am.
Inside
In the wrap.
where you are going to pack? Inside you are going to biological indicators?
It will be in between those, ma'am, inside the packet. In between those glasswares to be or anything that will be sterilized.
No, you are going to shape or you are making sterilize some, you are making some muslin wrap, right? You are going
Yes,
to
ma'am.
put the biological indicators inside that?
Yes, ma'am.
The package.
Avoid contamination.
So you have to, you have some, the scissors or something, some scalpel or something you have to sterilize. So you have to make a pack, right? With the muslin paper, right? Right?
Yes,
Am I
miss.
right? Okay.
Yes, ma'am.
So you are going to put the what type of indicators you are going to put inside that?
Strip
Wrap.
indicator.
Strip indicator, that's the chemical
Inside the
indicator.
wrap.
Okay. And then you are going to wrap it and the wrap is going to be taped with what?
The autoclave.
Autoclave
The
tape.
Autoclave tape.
autoclave
Okay.
tape.
Okay.
Mhm.
Then you are going to put inside the autoclave. Okay. So now where you are going to put the biological indicator then?
Inside the
Biological
autoclave.
indicator, doesn't it go in the package?
Inside the packages.
No. The inside
Like
of the
inside,
package is the strip
initially you put it, and then
indicator.
before wrapping it, at the top part of the wrapping, you put the indicator as well.
I think it will be somewhere in the autoclave outside.
Okay,
The
okay. So how many of you think you are going to raise hand? How many of you think that is going to go inside the Muslim package? Raise your hand.
no.
So Huda, Yusra, inside the packet, Kara,
Sorry, ma'am. Can you
Asnet. No,
please
it's okay. Okay,
repeat
so
the question?
okay. Okay, so one. Junaid also thinks Sabana, Asnet, Luis, Sabana, Asnet, Luis, Junaida, and what is the next one? Is Yusra, Huda, Rugiato, and
Is
Joanna. So you guys think that it should go inside the wrapper, right?
Yes, ma'am.
Inside
Yes, because
inside the
then-
wrapper, inside the muslin wrapper. That's you guys
Yes.
think,
Yeah,
right?
because then you know that it has penetrated
If
and
it's
everything
penetrated or
inside.
not. Yeah, exactly what I was
Yes.
going to say.
Okay.
Shayna?
Yes,
Sharina.
Okay.
Right.
Okay. So
Okay.
what are the others now? Okay. So now the rest. Now tell me, who thinks it should be outside the autoclave? Who has already raised your hand? Please clear it first. Please clear it. Who has raised your hand? Clear it. Rugiato, you did already clear your hands. Everybody has cleared? Okay. Okay. Now tell me who thinks, okay, so Bharna, Evelyn, and who else? Christiana only, and other doesn't know the answer. Okay.
Yes.
Okay, Fazardo think this one. Okay, just give me a second. Let me see. Jenaida thought the different thing. Louis, it's a different thing. Inghong, you think before? Inghong, you think is going to be inside or outside?
Sorry, ma'am. I didn't get your question. Sorry.
The biological indicators for the autoclave tape is going to be inside the muslin package or is going to be outside, inside the autoclave only? Outside the package, inside the autoclave.
Outside.
Okay, so you are in this team. Okay, Joanna already reported. Christiana, what do you think?
Miss, I think it depends also what you're sterilizing.
No, that's
But
not the right answer.
usually the procedure I think is for inside.
Okay, so you are in inside. Amina? 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 What happened to you? Amina,
Yes,
can you
ma'am.
hear? Okay, so what is your view? Outside the package or inside the package?
I think it should also be inside the muslin bag.
Okay. Santiago?
Yes, Miss.
What is the answer?
What?
Are you asking about the biological indicator?
Yes, I'm
Yes, she
asking
has
everyone
been
the
for the
same
last 5
question. Wake up,
minutes.
man. Yeah.
Sorry, I was over on my paper. It should be inside the wrapper.
Okay.
I think it should be in the chamber, in the autoclave chamber.
It should be in the
It should
autoclave
be,
chamber.
yes,
Yes.
inside
It
the
should
autoclave,
be
but not
autoclave
inside
chamber.
the wrap.
You have to put in different corners, upper level and
Yes.
lower level in the autoclave chambers.
Yeah, not in the wrap.
Not in the wrap.
That doesn't
Inside
make
the
sense.
wrap.
Ma'am, inside the wrap is
Inside the wrap is only the chemical strip.
chemical indicator,
Yeah.
yeah.
The
Chemical indicator.
is
And
strip.
outside the
inside.
wrap,
It's
outside the
biological.
wrap is going to be with the
Biology.
autoclave tape. The wrap is
Yes.
going to be the tape
Yes,
with the
ma'am.
autoclave tape. So there are two
Yes.
sets of indicators. And when the autoclave has the power of sterilizing or not, you have to use the biological indicators, and that has to be put inside the autoclave, not in the wrap.
Mm.
So if you put only 2 biological indicators inside the autoclave, you can understand whether the autoclave totally is sterilizing the things or not. If I put one inside the wrap, how you are putting 4, 5, 6 wraps, how you will be understand whether the one wrap is sterilized, the other wrap is sterilized or not. Right? You are putting the
I think
biological
that's
yes.
because in my mind, I think that the biological indicator to go inside of the wrap would then 100% guarantee that it has gone in and it has reached the
Then
standards
how
and it is safe.
it's not, because it may leak or something, it can, or if it not, then you are putting, say for 10, when you are in the huge autoclave, you are probably putting 50, 60 bags. Do you think
So
that
I
50,
think
60, 50, 60,
the
you cannot
the
put the biological inside each one?
yes, ma'am. The work of the biological indicator is to prove that the autoclave is actually doing the sterilization.
Exactly, sterilization
So
of the
it
whole,
has the outside,
everything,
inside equipment.
everything,
Yes.
all the material. So that you have to put it
Yes.
in the outside the wrap, so that all the materials inside the autoclave, you put it in the wrap or in straight. So which you are not putting in the wrap, like the glass things.
Yes.
Look at glass materials. When you are putting, you are not putting inside in any wrap. So then how you are going to understand whether they have been sterilized or not? Right? You are putting
That's
different
right.
things. Yeah. So you
Yeah.
have to put the biological indicators inside the autoclave, but outside the wrap at different corners. One is middle position in 4 corners, so that you know that from all sides it has been sterilized properly. Because in the same autoclave, maybe in one rack we are putting in the muslin wrap. Other chamber, maybe we are putting some glasswares. Maybe other
Right.
we are putting something else, right? So you
Yes.
need to be confirmed that everything has been sterilized, and that
Yeah.
is the biological indicators. Because biological indicator is not going to give you the instant result, right? Like the chemical strip or autoclave strip, they can give you the color has been changed, so you can understand. Can I just give an answer to the
Yes.
secrets? Okay, thank you. Hello.
Mhm.
No, actually, one of your colleague left me a voicemail that my medicine is ready to pick up today. So my husband is going to go and pick it up. We'll see. That's right. Yeah, yeah. Thank you very much for. Yeah, yeah, yeah. Thank you very much. Okay. Okay. Bye. Bye. Sorry. Thank you. So now is it clear? So you guys gonna not to make any mistake. Okay. So biological indicators
Yes.
is the most effective method for sterilization. Okay. So how you are going to understand that it has been properly sterilized, that is the use of the biological indicators. Chemical strip we put inside, but the biological indicators like the chemicals or the tape is going to tell you the color change immediately. But biological indicator, you have to incubate it for 24 hours in the water bath to make sure there is no growth, because we have actually what we have in the biological indicators. We have the spores, and our aim is to make sure sterilization can kill even the hardest spore form of bacteria. The live bacteria is going to be killed for sure, but if there is any spore in any sample or anything, we are sterilizing it. So we have to make sure that spore has been killed. And that spore, we have the hard spore in the samples in the tube, and we are going to put in the autoclave. If the autoclave is properly done, all spores in that biological indicator tube will be killed, will be destroyed. So even if you give them the favorable temperature, 37 degrees centigrade in the incubator, there will be no growth because they are all dead. That is the indication of proper sterilization. If there is any growth, if you see any change in color in the tube, any growth, that means the autoclave is not functioning properly. That's why even without your sample for sterilization, autoclave is being checked after few cycles with the biological indicators to make sure the autoclave is working properly or not.
Mom, where can we find this guide for autoclave?
We had learned in the LLSP. It said here, LLSP in the, okay, LLSP week 2, unit 5.
Okay,
So
I went
you
over.
understand everything is related. Okay. So now autoclave is clear for everyone. Okay. Now pH meter. Till now we didn't learn about the pH meter. pH meter, we learned a little bit. pH meter is to make the acidity or alkalinity of the solution, how much acidic or alkaline it is, and it depends upon the how much hydrogen ion concentration is in the solution. So more hydrogen concentration means more acidic, and more less hydrogen concentration or more OH hydroxyl, we call the OH is the hydroxyl, is called the more basic or alkaline. So to see more information about the pH meter, refer back to Chem D2L module. It's not done yet. An additional pH meter PowerPoint is in your unit in math for a quicker refresher. There will be some. So laboratory reagent water. So this you have to learn. Some questions even come in your ML how regarding the different types of water and what is the use of that. Laboratory reagent grade water is water that is suitable for use in a specified procedure and does not interfere with specificity, accuracy, and precision of assay procedures. That means it should not be, okay, this water has calcium, this water has more chlorine, this water has more sodium. So different waters cannot be used. So you have to have some water, which is, that's why you use the distilled water or different grades of purity of water. So which is free from all the factors which should not affect the specificity or accuracy or the precision of an assay procedures. It should not interfere or should not give any false indication or interfere with your test. So laboratory water needs to have inorganic and organic impurities in the water removed before analysis. The any inorganic, organic impurities, it should be removed. That is the rule. So levels of water purity, type 1 reagent water is the most pure. And there are two other types of type 2 reagent water and type 3 reagent water. But this, remember, type 1 reagent water is the most pure. This comes in question. Which is the purest form of water? Type 1 reagent water is the most pure. Now he's going to tell you more details. Type 1 reagent water is the most pure for preparation of standard solution, buffers, controls, quantitative analytical procedures, electrophoresis, toxicology, screening, enzyme analysis, HPLC, anything is going to be used the type 1 water. For any type of assay, any chemical analysis, anything, any making of solution which is going to be used for your analysis, you are going to use the type 1 water. Used immediately after it's produced, it cannot be stored because it's going to come, it's going to coming, you are preparing it, you are using it. Type 2 reagent water for qualitative chemistry procedures and for most procedures done in the hematology, immunology, microbiology, and other clinical test areas. So this is the type 2 reagent water. And type 3 for some qualitative laboratory tests such as general urine analysis, you doesn't need that much pure. Can be water source of preparation of type 1 and type 2 water. So type 3 water can be used for making type 1 or type 2 water. Obviously it goes from type 3 water can be used for washing, rinsing laboratory glasswares. But any glassware should be given a final dish with either type 1 or type 2. So final at the beginning, you are making the soap, these, that, so you can wash it with the type 3 water. But after everything is clean, you have to rinse it with type 1 or type 2 water, depending on the intended use of the glassware. If you are using this glassware for very critical things like the enzymology or toxicology or electrophoresis, high tech analysis, you have to final this with type 1. if you are using something for, microbiology or hematology, so you can wash it with the type 2. So that generally nowadays it doesn't matter, but you have to do it here, learn it, and you have to pass the exam. Storage of reagent water. Type 2 and type 3 water can be stored in borosilicate glass or polyethylene bottles, but should be used as soon as possible to prevent contamination with airborne microscope. Container should be tightly stoppered to prevent absorption of gases. It is also important to keep the delivery system of the water protected from chemical or microbiological contamination. So how you are going to store it? You have to store it in a borosilicate or polyethylene bottles. It has to be very tightly capped, and try to use it. Don't make 5 liters in a day. So try to make it daily use so that it can be prevent from contamination with any airborne microscope. Because even you are not putting anything, touching anything, but you are opening the cap and closing the cap, so that time it may contaminate. So generally these type of bottles, they have a dispenser in the like the tap dispenser, so that it doesn't open, the cap from the top. So we generally dispense it, wipe it with alcohol and leave it. Purification of the water processes. Two general methods are employed to prepare water from laboratory use: deionization and distillation. Distilled water is double distilled water. Then we have deionized water, combination of deionization and distillation, reverse osmosis, other processes for purification. Oh my God. So what is distillation? Both types of distilled versus deionized water. Both types of water are purified by through different purposes. Distillation uses heat, heats the water until it's vaporized. Steam is collected in a sterile container where it condenses and becomes water again. Contaminants are left behind as their boiling point is higher than water. So you are boiling taking the water, impure water, you are boiling in a container. You see the round bottle, those type of bottle, they are going to put it, boil it. And when you boil the water, you see it from the steam. When the steams come, the steam is coming through a long tube and then is going to collect it in another container. So the steam is getting again condensed to water, and that water is free from other things because the water boiling point is much lower than the other one. So only in the steam, only the water comes, not any others. That's the contaminants are left behind as their boiling point is higher than water. Deionization use ion exchange. So when there you have to measure sodium ion, potassium ion, or any critical calcium, and ions in your system, then you cannot have any additional ions in your water system or the solution or what you are making. So those water has to be free of any ions. So that is deionization, means it is using some filtration system where the all ions is going to be blocked through a membrane. So water goes through an initial filtration system, physical or carbon, and a reverse osmosis membrane. Osmosis, So what is then sent to a DI system, which contains two types of resin, cation and anion, which is going to be blocked. Two resins act as positive and negative ions. So the calcium or potassium or any other negative ions, chloride ions, bicarbonate ions, anything OH, so and then replace with the hydrogen and hydroxyl. So whatever the ions they have transport. It's very complicated. They take out all the ions, only they can release to go hydrogen and hydroxyl ion, which is the component of the water. The hydrogen combines with hydroxyl ion and becomes water because H2O, see the 1H, 1H, 2H and O, H2O. So basically, deionization uses an ion exchange method which it stops or attract. This ion exchange attracts all the positive and negative ions and replace them with the hydrogen and hydroxyl ions. So whenever you the ion-free water, then you have to use the deionization exchange or this one. Okay. Next, quality laboratory reagent, water quality control. Quality control means the control whether it is really giving you the constantly keeping you the quality of the testing. Every point quality control has been checked. Quality control and impurity testing. Testing at periodic interval should be included for microbial monitoring, resistivity, pH, pyrogen, silica, organic contaminants for the laboratory water. So they are going to send you for the quality control to check whether everything is in your range. So reagent preparation. A reagent, what is reagent? A reagent is defined as a substance used to produce a chemical reaction. So instructions for preparing a reagent, identify the names of the chemicals needed. Obviously, what chemicals you need, how much you need in grams or milligrams, how much you need, the volume or the amount, and then total volume where particular reagent should be diluted. So you have to make 0.85% saline. That is the reagent you are going to make. Or you are making the bleach. You are using liquid to liquid, but you are measuring something, you are adding something, right? So there is a name of the chemical which needs to be diluted. In case of bleach is a bleach, and then you are making the reagent, hypochlorite, 1% hypochlorite reagent for your cleaning solution. So then you are adding the rest of the water to make it a reagent. Same thing, if you have to make a saline, 0.85% saline. So you need the saline here, how much you need and how much volume you need. If you need 0.85% saline, 100 ml, percent always means that amount in 100 ml. 100 ml. So 0.85% means 0.85 gram in 100 ml. So you have to weigh 0.85 gram of sodium chloride for making a saline, and then you have to dissolve in 100 ml. So that's a still name, chemicals needed, name of the chemicals needed, number of grams or milligrams you needed, and the total volume to which particular reagent should be diluted. If I tell you to make 0.85% of saline of 1000 ml, how much sodium chloride you need?
8.5.
8.5, because is 1000 ml is 10 times more than the 100 ml. A percent is always that amount in 100 ml. Okay. So solvent most often used for dilution is deionized or distilled water. The water you are going to use is going to be deionized or distilled water depending upon what is going to be used for testing. Thank you. 2 minutes. So the highly automated clinical laboratories, very few reagents are prepared by laboratory staffs. These are mainly you just purchased. In case of only water or buffer needs to be added to a pre-packaged reagent. That means they are going to come in a concentrated solution. They will tell you to dilute it. Nowadays, we used to make everything. Till now, in the research, you have to make everything. But nowadays, in the lab or clinical lab, everything is coming to ready-made. But you have to know the basic in case. Now, grades of chemicals. Analytical grade, reagent grade, generally equal to SCS grade. So SCS grade and analytical reagent grade as equal. It is 95% purity, suitable for lab and analytical application. Chemically purified grade means to official standard, not pure enough for food, drug, and medical use. So generally, in our case, we doesn't use the chemical grade. USP, United States Pharmacopoeia, used for most lab purposes, ensure grade is appropriate for methodology. We don't use the USP one. NF grade meets or exceed requirements by the National Formulary, USP NF, jointly published book of chemical standards. a technical or commercial grade used for commercial and industrial purpose, not pure enough for labs. So basically in the lab, we use the ACS or analytical grade reagent. That is the purest for using in the lab. We never use the commercial grade is used only for the commercial purpose or industrial purpose. USP they use in the United States. We don't use it. Generally, whole world doesn't use this except the United States. Maybe they use it, but I worked in the United States. Even they doesn't use that unit. We use the ACS or analytical grade. And chemically purified grade is not used for our purpose. It can be used for different chemical, chemical laboratory or something, but it's not for the clinical drug or medicinal use. So which grade water generally we use? We use the analytical or ACS grade. What is the difference with the ACS grade and laboratory grade? ACS grade means the exit purity standard set by the American Chemical Society acceptable for food, drug means 95% purity. Laboratory grade most popular for educational application, but its exact levels of impurities are unknown, good for training and teaching. Okay, so for training and teaching, we can use the laboratory grade. For in actual thing, we have to use the ACS grade or the analytical grade. So reagent used in laboratory, assess chemicals, hazard chemicals communication policies, reference materials about the individual chemicals are provided by the chemical. These you have already have learned from the what is called WHIMIS. Okay, so this is the part of the WHIMIS, hazardous chemical communication policies. Reference materials about the individual chemicals are provided by all chemical manufacturers. That is the safety data sheet. That's the WHIMIS, right? They are going to give you all the hazardous chemical information. And this information accompanies the shipment of all hazardous chemicals and should be available in the laboratory for anyone to review. The material safety data sheet should come with your chemicals and it should be kept in a binder. And also you can see it in the what is called computer. If you have the time or that time, you can go to the computer. So SDS contains information about possible hazard, safe handling, protective measures, storage and disposal of the particle chemicals if accompanies. You have known that SDS. You have storage of chemicals, read the label. Some require immediate refrigeration or freezing. So whenever any chemicals comes in the lab, your first things to look at what is in the SDS. What is the storage condition? Where do you have to storage? What is the storage in the room temperature? You have to cool in a dry place. You have to keep in a biological safety cabinet, or you have to keep in the chemical safety cabinets. How you are going to store acid and base. If there is a gas cylinder, how you are going to flammables or solvents, how you are going to keep it. So you have to know everything about the storage. That is very important for your lab safety and your safety. So some require immediate refrigeration or freezing. Store solids in a cool, dry area. Acid and bases are stored separately in well-ventilated storage unit. Special consideration, flammable solvents are stored and labeled as per OSHA regulations. Acetone and ether are stored in special safety cans and in approved storage units. So these are going to be HAPs. In lab, in our lab, we doesn't carry so many things, right? So, but you guys know what to keep it. And don't scared, you have to know for your, practicals or the theory or exam here. But when you go to any lab or anything, they have already specified area. So you know everything is labeled, what to keep where. Fuming and volatile chemicals are only opened and prepared under a hood so that vapors will not escape into the room if there is any volatile or fuming. So reagent used in the laboratory assays, concentration and materials, reference material. Concentration of solution. What is concentration? Substance being measured in analysis whether the organic or inorganic high or low molecular weight are solutes. Whatever you are weighing and how much weighing and how much it is in the diluent is the concentration. The substance in which a solute is dissolved is called the solvent. So what are the chemical is called the solute. Where you are dissolving is called the diluent or the solvent, or then combined they call the solution. So solution is made up with a solute and a solvent. So you are making saline. Okay. How you make the saline? You dissolve the sodium chloride in a specific amount to a liquid, right? The water, distilled water or deionized water, right? So here, what is the solute? Sodium chloride is a solute. What it is you are putting it to dissolve? Water. Water is the solvent. When you mix together, it's going to make a sodium chloride solution. That is the solution. So solute plus solvent is equal to solution. And it depends upon how much you need it. Was the 0.1%, 2%, this millimole, these things. It depends upon what type of solution it needed. You have to use then what chemical you have to use, what type of solvent you are going to use, and how much you need to do it. So buffers. It said buffers. Yes, buffer means which buffering. We all know we have to buffering between our families sometimes, right? So buffers are weak acid in lab, in chemical analysis. Buffers are the very weak acid or bases. They related to salts that are result of the dissociation characteristics. So it is basically buffering, minimize the changes in the hydrogen ion concentration so that it doesn't go up or down. Hydrogen concentration is often expressed as the pH, and pH scale, you guys, ranges from 0 to 16. And what is the neutral pH?
7.
7.
7.
6. 7. Oh, 7, 7, 7.
What is our blood pH?
7.5 or so.
35 to 7.45.
7.425. Good. So you guys have to remember those things, okay? It can come any questions.
Yes.
So transfer and dilution of chemicals per reagents. In quantitative transfer, the entire amount of the measured substance is transferred from one vessel to another for dilution. So when you are making the saline or something, whatever we told you, so that is the transfer and dilution. Transfer the whole amount and dissolving it. Then you have to label the reagent or container of storage reagents, usually reagent bottles where you store the solution or the reagents. It should be stored in a reagent bottle which has a cap and should be labeled before the material is added. Before you add the material, you have to make a label. Reagent should never be placed in an unlabeled bottle or container. If an unlabeled container is found, the reagent must be discarded. If you see something in your refrigerator, in your cabinet or anything unlabeled, don't ask anyone. It's just discard. If anyone asks you a skin, it was not labeled. So take a picture and keep it if, to avoid any arguments nowadays. Okay? How to do a quantitative transfer. Quantitative transfer refers to the procedure where the entire amount of weight of solids transport the dilution vessel. Let's open the quantitative transfer method document in Unit 3 in D2L and allowing the example. It's not done yet. So say for example, if you have to prepare 50 ml of 5% weight by volume calcium chloride using distilled water as the solvent, one calculation have been made. Procedure is as follows. Accurately weigh the chemical 50 ml of 5% weight 5 volume. Tell me how much you need. 50 ml of 5%. 5% means 5 gram in 100 ml. Is that right? 5% means 5 gram. Is that right?
Yes.
Yes or no?
Yes, ma'am. Yes.
Yes?
Yes.
Yes.
So weight by volume means you have to weigh this calcium chloride, and you have to volume means how much volume or the diluent you have to add. That is called the weight by volume. So if you need 5 gram in 100 ml, how much you need for 50 ml?
So, have calculation.
2.5.
Ah,
What?
2.5.
2.5. Yes, 2.5. So you need 2.5 gram. Okay? Is that clear? So for 100 ml, you need 5 gram. Right? So 50 ml, you need half. So you have to calculate like that. So using it as solvent. So what you are going to do, you are going to accurately weigh this amount, 2.5 gram of calcium chloride using your balance. Then you are going to transfer this one to a volumetric flask. Okay? 50 ml volumetric flask. Here is going to give you the accurate measurement. Then what you are doing? You transfer it, then you are adding the distilled water. It said distilled water as a solvent. So we are adding the distilled water up to the mark in the volumetric flask. Where is the 50 ml? Mark is there following the meniscus. Okay, so then you are going to cap it and you are going to dissolve this entire thing. And then after once it's done, then this is labeled. Then you are going to transfer in a reagent bottle, which should be labeled to, what is going to be labeled? 5% calcium chloride solution. That should be the label, 5% calcium chloride. Okay, so that everybody is know that this solution is 5% calcium chloride. Then you are going to transfer in the reagent bottle with the stopper cap. So that's you are saying, place a clean dry powder funnel into the mouth of a labeled volumetric flask and carefully put the chemical into the funnel. Okay, so you put the chemical into the funnel. Then you are adding next the distilled water. Okay, so they are showing in the pass-through pipette. We doesn't do that 50 ml. See, if you have to do the pass-through pipette, it will take forever. So we just fill up to something beneath the level of the meniscus. We just pour it in the funnel and then we add it with the pass-through pipette so that it comes directly to the level of the meniscus. This is the funnel with distilled water. So because whenever putting the funnel, so first, so your funnel, you are pouring the water. So when you are pouring through the weighing board, some is getting stuck into the funnel. So that's why you are adding the water through the funnel. Otherwise, we can take out the funnel. What is the need? So because there may be some stuck in the funnel. So you are going to pour the water, rinsing the funnel. Make sure it doesn't go over the meniscus. Do slowly. And then after that, you are going to put through the pass-through pipette to make up to the meniscus. When is 1/3 full, so you are going to do that one. So this is the, do not put the stopper on the flask at this point. Dissolve by swirling or using a magnetic mixture and stirring bar. So basically what we do in reality, when is 1/3 full, we just try to stir it so that the solution can go mix. Okay, slowly, because if you do the pour whole thing, it's going to be difficult to mix. So here we swirl it. So when it's done, then we slowly fill up the volume, again swirl it, and then finally we fill up the volume and then put the stopper. That you already told, stopper. Yeah, when you with the stopper, you can put, generally we don't do invert that one, but with the sidewise, the like you, the how invert the tube, so we just do that one so that it can mix properly. How to perform a quantitative transfer with appropriate SDS information. So 5% calcium chloride. Okay, so they are telling, rinse the label reagent bottle lid and 1 to 2 ml of prepared reagent to be removed, contaminants and discard, rinse properly. Okay, Oh, that was the continuation of this one. Okay. Oh, that is the reagent, how you are going to transfer in the reagent bottle, calcium chloride. So this bottle is labeled, we already told. Rinse the label reagent bottle and lead with 1 to 2 ml of prepared reagent to remove any contaminants and discard. So whatever you have made here, just rinse with that solution. Little bit, take a little bit solution and rinse with that one, the cap and the lid, so that anything inside is not going to hamper or contaminate. So then you are going to pour this one in this reagent bottle. Then you are going to cap it and store it. Checking a reagent before use. A reagent log should be kept to indicate product name, date in use, expiration date of the reagent, and lot numbers of controls after the reagent has been checked. This is indicated on the label, and the solution can be used for the laboratory testing. So you can see how long, I don't know whether I can zoom it. You can see there, this did 5% calcium chloride. So they put this one like this, but generally you can put it when you made it, who made it. So this is generally we put it. We put the name of the solution, okay? Then when you made it, if there is any expiry date, like the one week, you can use in 1 week or the 1 month. So you can just date of expiry approximate. If there is a danger or anything, you can write it down and who made it. So you just do that like this. When the ready-made commercial reagents come, check the label for product name, expiration date of reagent when you are receiving the ready-made chemical reagent. Storage requirements, ensure this has been followed. Date, time opened when you open the first one, and also there is a log book, how much you are using. Generally in the lab, say I am using calcium chloride, so it comes a 100 gram packet, right? So number day 1, this day, how much use, who used it. And if there is multiple lab are using, you have to write the name of the labs. Of which the next day, so you guys know 100 gram we have used, this person has taken 2 gram, this person has taken, next person has used 5 grams. So there is a list how much is left. So in the inventory, it's going to be useful for you. So 100 gram, first day somebody has taken 2 grams. So what is amount is left? 98. Next day another person has taken with the date, initial and everything. So probably 10 grams. So 98 minus 10, 88. So that way you know how much chemical is left. That is the record book. You have to keep it. At the same time, if you can track if there is any mistake, any contamination, anything at which point it happened. You guys know safety when working with acid, you have to add the water to acid, right?
Yes, ma'am.
Water to acid?
Water to acid.
Acid to water, ma'am.
Acid to water.
Acid to
Oh,
water.
acid to water.
Acid to water.
How many of you agreed? Acid to water and water to acid.
Acid to water, me.
Acid to
Oh,
water.
yeah, it's acid to water,
Acid.
ma'am.
Acid to water.
Yeah, acid to water.
Acid to water.
Okay. Luis Santiago Inghong has no response. Christiana has no response. What do you want? Acid to water or what to acid? Acid to water. Everybody agrees that?
Yes.
Savannah
Yes.
probably
Yes.
Savannah probably went to draw for kids school. Yeah. Let me see the next one. Maris,
Yes, ma'am.
what do you think?
Acid to water.
Acid to water. So why you didn't raise your hand? Huda?
Oh, I thought.
Okay.
Okay.
Okay. Rugiato raises hand. Aslan. Okay. So that's good. You have to water. Only Evelyn, why you made a mistake?
Yes, ma'am. No, I got confused there because I was reading also the
Okay.
D2L PowerPoint.
So acid to water. You cannot water to acid because acid is more concentrated, right? Down.
Right.
If you add the water, it can start boiling. It can splash.
It
So
will
that's why
spray.
water is when you have the water and you're putting the acid, is slowly diluting. So it's not going to splat and there will be no injury or an accident. Okay.
Yes, ma'am. Thank you.
So in diluting acid, there are rules to follow. For acid solution, the water must be accurately measured first. Then the desired amount of acid is added. In another word, we always add acid to water. Slowly, then mix gently. Okay?
Acid water slowly
Acid
mix,
to, yeah.
slowly gently. Slowly, then mixed gently.
Mm-hmm.
Then mixed gently.
Gently, slowly, very slowly.
Sorry, mom.
It's okay. Why sorry? Okay. Safety when working with acids. In adding water to acid, the water does not mix initially, but will just layer on the top of the acid and chemically reacts with the acid, generating heat and causing an acid to spit and spray. That's why you are not going to add water on the acid. That's why they told what I told you. So what is going to happen? Water, when you're pouring on the acid, is not going to dilute. It's going to sit on the top and started splashing. Okay? It's because when the water comes with the acid, it generates the heat. And from the heat, it causes the exothermic, that is called the exothermic reaction, and which cause acid to spit and spray, and which you may got hurt or accident. The water, if the measured first and the acid result in the small amount of the acid is immediately diluted by the larger amount of water. That's why telling you are adding acid to water. What is happening? Water is down, you are putting the acid. So acid is going to the water and slowly is getting diluted. That's why you can avoid the hazard spitting. So we are done for this one. It's okay? Done, 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 done. What is the next
Yes,
one?
ma'am. Yes.
pH we have learned. We are going to learn a little bit. Okay. Okay. So this is unit 3 pH. How many we have? Under unit 3. So this one quantitative percent. This one I did, right? Volumetric flux. This one I did. Transfer method. Oh, you go for break, then you will start the next one. Okay.
Yes, ma'am.
Otherwise,
Thank you.
otherwise,
ma'am.
Asnet is going to be upset.
We didn't hear from Asenet.
Yeah, right. It's right. We didn't hear anything from her. She's not today. She's not hungry at all.
Okay, mom. See you at 11:30.
Here.
Okay, yeah.
Okay, 11:30. Okay, thank you, Miss.
Thank you, Miss, for break.
Oh, now she wake up. Okay.
Okay, yes. Thank you, ma'am.
Okay. Thank you. Okay. Hope everyone has a nice break. So let us go back to our session. And who is still not here? Only 17 people rounds up. Who is not here till now? More people. One more people is missing because Alexia is absent today. Can you figure it out? Who is not joining? Luis is here. Evelyn, Savannah, Inghong, Cristiano. Who is missing now? Except Alexia, who is missing? Rugiato is here too. Santiago is here. Yeah. Isra is here. Who is missing there?
Asinet, ma'am.
Huh? Who?
Asinet. I didn't see her name.
Yeah, I seen it. Maybe she's eating too much. She'll be back for sure. Yeah. For
Yeah.
her, only I have to start. That's why. Yeah. Okay. Let us start. So we are going to, you already learned a couple of things, pH meter and other things. What is the pH? pH, we already know, is a measure of hydrogen ion concentration in a solution. So what pH tells you? pH tells you whether the solution is acidic or alkaline. How it measures? Depending on the hydrogen ion and versus hydroxyl ion. Which is more acidic is going to have more hydrogen concentration, more hydrogen ions, and which is more basic or alkaline, less hydrogen ion, more hydroxyl ion. So what is the better? If you see the pH middle, you will know that pH 7 is the neutral, it's the middle, and pH can vary from 0 to 14. So 7 is the neutral pH, and the pure water pH is always neutral. Urine is little bit acidic, saliva is little acidic. As you go back to this side, is making more acidic. So it's going to be like the battery acid is extremely acidic. It is going to burn your hand if you hold it with the bare hand. HCl, what we have in stomach, you can understand if the HCl production is too much, how you got the acidity. If your body is not functioning properly, your HCl is generating too much, or so then you feel the acidity. Acid is generating and you feel acid, and that too much acid is harmful because it's going to eat your stomach lining. Instead of acting on your food, it is in excess. So it is going to cause acidity, burning sensation. That is the HCl, stomach acid. Lemon juice, vinegar juice, these are orange juice. These are all acidic, depending upon the how much acidity, how much hydrogen ion concentration is there. In the other side, if you go up, so seawater, we have a little bit more alkaline than pure water. The baking soda we use, ammonia solution, soap is more alkaline. Bleach oven cleaner, it looks like a bleach, but the oven cleaner in the bleach is more alkaline, and the drain cleaner which we open for cleaning our drain is highly alkaline. So maybe they are going to give you a couple of examples like the lemon juice or vinegar or acid rain or HCl in stomach, whether they are acidic or what is the range of acids. What is more alkaline, baking soda, seawater, pure water, or they are going to give you acid rain, seawater, or ammonia solution, which is more basic or more alkaline. So pH scale, we know 0 to 14, pH 7 is neutral, where the concentration of hydrogen ion equals the amount of hydroxyl ion, that is the OH, equal amount of hydrogen ion and equal amount of hydroxyl ion. So thus they neutralize each other effects. Pure water is neutral pH. That questions come. What is the, they will give you options, multiple options, which is very close to seawater, pure water, you know, different types of water. They may what? The water is neutral. pH is 7. Acidic pH occurs when you have the hydrogen ion in excess, more hydrogen ion comparative to the hydroxyl ion. Say, for example, 2 hydrogen ions, 1 hydroxyl ion is going to be more acidic. 3 hydrogen ion, 1 hydroxyl ion, more acidic. So is that way? Too much hydrogen, depending upon the concentration of the hydrogen ion, is going to be more acidic. And depending upon the less hydrogen ion or more hydroxyl ion is going to be considered the more alkaline. How acidic is determined? By how great is the excess. pH value below 7 are acidic. The lower the pH ending, the more acidic the solution. That's we see in the chart. Alkaline is opposite. When you have hydroxyl ion more than the hydrogen ion. Alkaline is determined how great is excess of hydroxyl ion or less hydrogen ion. And pH values above 7 are alkaline, and alkalinity depends upon how much you are going towards the right end. That means more hydroxyl ion and less hydrogen ions. So this is the hydroxyl ion. It looks like this. Okay. Example of acids, lemon juice, vinegar, hydrochloric acid. So everything you have lemon juice, everybody needs a citric acid. Vinegar is our acetic acid and hydrochloric acid is HCl. Okay. Alkaline solution, the commonly used, they are giving you the commonly used. Hydrochloric acid we use in the lab, vinegar we use in lab and also in here. In lab, we use acetic acid and at home you use as a vinegar. Lemon juice, you all eat, drink, everything. So examples of baking soda you use at home, right? So baking soda is the alkaline, sodium hydroxide, potassium hydroxide. Those are examples of alkalinity.
Sorry, I was having problem getting on. I don't know what's happened to my laptop. Sorry.
It's okay. It's okay. You are in. Yeah. You understand. You are back now. Yeah. I know Asnath is going to come back, maybe taking a little bit extra breakfast. That's what we thought.
No, I'm sitting in front of my laptop and I saw Amina and Inghang, but they're stalled. And I'm like, okay, I'm still waiting for people. And I look at the time and I go, wait a minute. And Christina called me. That's when I know that I'm actually not in class. So right now, my laptop is still stalled. I can't get onto it. I don't know what's happened. But thank you.
Okay, no problem. Let's see how the friends teamwork works. They called you to inform you. Thanks, Christiana. Thanks, Christiana. That's the teamwork. Really good. Thank you, Christiana. Yeah, you all help each other. That's I really your team is very good. Very good. Yeah, thank you. Okay.
Well appreciated.
Yeah, thank you. We all learn for each other, right? So pH meters. Accurate pH readings are measured by a pH meter. The name of the instrument is the pH meter with an attached pH electrode or probe. This is called the electrode or probe. Here you dip this bulb. This is in the solution and then is connected with a probe, the electrical things. And here is going to go into an instrument, is going to tell you the pH. The probe has a glass bulb. This is the total probe. It has a glass bulb, okay, on one end and an electrical wire in the other end. The wire sends data to the meter when glass bulb is dipped into solution. So when you put the glass bulb in any solution, the wire is going to reading the hydrogen and hydroxyl ion. That is the electrical current they measure, and then they are going to send through the wire to the instrument. So the pH meter senses difference in the electrical charges, what I told. The hydrogen and hydroxyl is again electrical because hydrogen is a positive ion and hydroxyl is a negative ion. And electric probe cannot understand whether the hydrogen or is the hydroxyl. It can understand whether there is a positive or there is a negativity. The pH meter has been set like that. So it use the electrical recognition system to see the charges between inside and outside of the bulb. What is the inside and outside of the bulb? The outside. So the electrical charges outside the glass bulbs are related to the concentration of hydrogen and hydroxyl ions in the solution. So whatever is outside, whether it is more hydrogen ion or more hydroxyl ion, the outside the bulb, this bulb is recognized that amount, how much is presence of hydrogen or hydroxyl ions. The difference in charge between the outside and inside surfaces of the glass is called the electrical potential. The difference between the inside and outside is called the electrical potential. And the voltage created by the electrical difference between the two glass surfaces causes hydrogen ions to flow across the glass and current flow through the wire. That is not needed to know that much. So that is, you can just see the glass bulb. Outside the glass bulb, what is the pH? That is the hydrogen or hydroxyl ions. It is going to be measured through the electrical potential or the electrical charge difference between the inside and outside bulb. And this current difference is going to be in measures of voltage. It goes through the wire and is going to show you in the instrument what is the pH. So the current generated is very small and the voltage or if cannot be direct measured. The measuring electrode is connected to a meter to a reference electrode which is also placed in a solution to form an electrical circuit but is not affected by the solution. No need so much. The reference electrode has a stable measurable reference voltage which is only affected by current. No need. So basically you can see what you are doing. So this is the solution. The resultant fluctuation in the voltage of the reference electrode is what is actually measured. So basically what is happening? So we are putting the solution, the glass bulb is dipping here. It is measuring the ion concentration, whether hydrogen or hydroxyl ion concentration is sending through the wire and there is a reference electrode. The reference electrode is basically multiplies the signal as it did in the ECG and then is going to give you the reading here. 6.88. It is giving the pH meter 6.88. Whether this is neutral or acidic or alkaline?
Acidic.
How much acidic? .88 is almost equivalent to what?
Neutral. 7.
Neutral.
Slightly
Newton. Very weak acidic. Okay. Okay.
Yeah.
So now tell me, if we need this solution to make the pH 8, what do you have to add?
A base or an alkaline.
Base.
A base or alkaline
solution. Base or the alkaline solution is the base. We generally use sodium hydroxide or potassium hydroxide.
Yeah.
Okay, until and unless there is specifically measured for some chemicals which may react. So generally we add slowly and then stir and then we wait until the pH shows slowly go up, and when it's going to be almost 8, it's going to stabilize. Then the pH is done. If, say, example, this pH, I need the pH to 4 for my working solution or for working assay or experiment, I need the pH 4. What you are going to add?
Acid.
What acid?
Acid.
Which acid we generally use?
Hydrochloric acid.
Hydrochloric.
Hydrochloric acid. Vinegar is acetic acid. It doesn't tell you the exactly hydrogen concentration. HCl is directly generating the hydrogen donor. Okay?
Hydrogen, yeah.
So change of voltage in the reference electrode is measured in millivolts and relate back to the number of excess hydrogen or hydroxyl ions present in the test solution, and it converted into pH reading. That's the converter, which from the here they convert, like the ECG transfer convert, the galvanometer convert the electrical to mechanical. So here these electrodes is generating the reading the electrical difference of the hydrogen and hydroxyl ion, then is going to the reference electrode, and this reference electrode is amplifying the signal, and which is then converted into a pH reading through an transformer. I am not an instrument person. Whatever I learn, I am going to tell you. Okay, so pH formula, this you have to remember. The formula used to calculate pH is pH is equal to minus log hydrogen plus. Okay, so if you do like this, what is pH is equal to log minus 2. So pH is equal to minus 2 and minus 2. What we learn, minus and minus is going to make plus 2. So hydrogen ion concentration is 0.01 millimole per liter. That means millimole per meter, 1 by 100. That means 1 by 10 into how many you have? 2. So 10 to the power minus 200 is going to 0.1 millimole. So it's 100, 1 by 100. So it's minus. So negative 2. So there is another example how is going when is 0.01 millimole, pH is minus 2. That is the strength, means more acidic. When concentration is 0.1, so it's going to 1/10. So that is 10 to the power minus 1. That's how they are calculating this, are showing you, okay? A change of 1 unit of the pH scale represents a tenfold change. Always there is a 10. pH 2 to pH 1 to pH 0, everything is 10. pH 2 means 0.01 millimole per liter of hydrogen ion concentration. pH 1 is 0.1. pH 0 is 1. That means there is nothing hydrogen concentration. It's a logarithmic scale. It's got 10 times, always, back and forth. Is acidic or alkaline. So that means a solution of pH 3 is 10 times more acidic than a solution of pH 4, right? pH 4 is 10 times more acidic. Is 100 times more acidic than a solution of pH 5 because it's going to more neutral side. 1000 times more acidic than a solution of pH 7 and 10,000 times than pH 7. So it's going to 10. It's a 10 times 3. So here 1 to here 10. Here times 10 times 10. So it's going to be multiplying. 3 is 10 times than 4. Another 10 times than 5. So 4, 10 times time. So 100 times than 5. Similarly, is 10 times 10 times 10 is 10,000 times more for than the pH 6. And again is 10 times 10 times 10 times 10. So it's equal to 10,000 than pH 3. And obviously, if you increase more alkaline side, it's going to be 100,000 times more than pH 8. Is okay? Hello?
Yes, ma'am.
It's okay.
The constant
Yes,
value
yes.
is 10 times.
Yes.
10 times. If you go up, it's going to be the same thing.
Yes.
So pH is inversely related to hydrogen ion concentration. pH 2 means 0.01, that is the minus. pH 1, 0.01 mole per liter. pH 0 is 1 mole per liter of hydrogen. Where in the neutral pH, it's a pH 0 means there is nothing. So maximum acidic, 1 mole. This is less, 0.1 millimole. This is 0.01 millimole. So at least the less hydrogen concentration is going to be theoretically more alkaline. More hydrogen concentration is going to be more acidic. Current meters combine the glass measuring electrodes and the reference electrode inside one probe. Nowadays, they doesn't have the two. So inside everything is in one. pH is temperature dependent. So some models have additional temperature sensing probe. So the meter can automatically correct for temperature. Generally, we read the temperature at room temperature. But sometimes if there is a hot and cold, or sometimes the solution is needs to be little bit heat or something for the dissolving of the things. So some pH meter has some temperature probes, sensing probes, and they can adjust it. So these are the different pH meter. These are called the handheld pH meter or portable one. This is portable one. You can carry it and measure it. This is in the laptop, so it can stay and do that one. So there are different types of several pH meters. pH adjustment, I already told you, if the checking the pH solution like agar media or anything, any solution, and pH is not what is desired. If it is too low, add a few drops of concentrated alkaline solution. If it is too high, add a few drops of concentrated hydrochloric acid, or you can add acetic acid, but it's not recommended until and unless it's mentioned in your protocol. But if it is not too low, but you have to add to make the pH to alkaline side. Say you have pH 7, you have to adjust to pH 8. Are you going to put concentrated alkaline solution? No, it's going to immediately jump up to 10. So that time you have to dilute the alkaline, that the sodium hydroxide solution, to 1/10 or 100, and then you have to add drop by drop. So it will experience, when you do that, you will experience. Except the pH meter, for instant measurement, we have pH meter. Papers are treated with pH indicator solution and dried. So if you drop the pH meter, and it will tell you the pH, because in the pH paper strip, it gives you the direction. The pH is in the paper. What is the pH? It will going to change the color, and seeing the color change, you can know that what is the approximate pH. It's not the exact, but you can get an idea of what's the pH of the solution. Is the highly acidic or towards neutral or more acidic or alkaline? So deep pH paper in the test solution, people will turn different color based on the pH on the test solution. Color is compared to a color chart to determine the pH. pH safety, use care when adjusting pH using acids or strong alkaline solution. Both are caustic and can cause chemical burns to skin, eyes, or breathing passages. So be careful, use your proper PPE. Spills must be wiped up immediately. If acid or alkaline solution is dripped, first you neutralized. Disconnect pH meter from power source before repair. For any repairing, always disconnect the pH meter from the power source. pH quality, follow manufacturer's instruction for use and storage. That is always, electrodes must be handled carefully because it's a glass, so as not to damage glass bulb. Electrodes are stored wet in an electrode storage solution, not water. So what you do, you are going to, after you use, you are going to wash the electrode, because you use that one to do the different pHs, right? So what you are going to do, you have to wash with the distilled water, and then you have to dip the electrodes. Electrodes will never be dry. If it dry, it's going to ruin. So you have to always keep in an electrode solution. It's kind of the pH. There is a 3 pH value standard solution we can buy. So that is the pH value. You can put in the 4, 7, or 10. Electrode must be calibrated each time before doing the pH. So whether pH is working properly. So what you are going to do, you are going to wipe it, wash it, then you are going to dip the electrode from the standard pH 4. Check the reading whether it's giving you 4 or close to 4. If it is not, you have to calibrate it and adjust it to 4. Then you have to calibrate it with the pH 7, which is a neutral pH, and also 10. Especially if you're working around the neutral pH zone, you have to make sure it's giving the, when you are giving the standard pH 7, it is giving the value 7, or pH 4 or pH 10. And then If it works properly, then it's fine. You can measure your pH, what the solution, what you are working for. So electrodes are immersed in calibrators and pH meter is set to read those values. It's done. Any question on this? How to clean a balance we did. This one we did, right? We already showed this one. Okay. What is the next? What is the time tool? So we can start this one. Did you learn about the reagent preparation calculation with Saina?
No, ma'am.
Okay. Did she teach you about the weight by volume, C1,
She
V1 or
discussed
S1?
only the
Yes, yes, ma'am.
formula.
C1V1.
Only
Yeah.
the
Yes.
formula.
Yes, the formula.
Okay. What the formula means?
The formula means it's a concentration and a volume of a certain solution, ma'am, that will be equal to the final concentration that we are going to measure.
So
For the concentration or the final volume.
Yeah.
C2.
So what is
Solvent and
yeah.
solute.
Okay.
Yeah.
So I already discussed what is solution means. Is solution is made up from two components, right? Two or three components, but main is one is solute part. Solute may be one or two or three, depends upon what is you are making. But it is made from the solute and the solvent. Solute is the thing which is going to be put in the solvent. Solvent is the liquid, and solute can be liquid, can be solid, can be gas, anything which you are going to be dissolved in another substance, so in the solvent, that is called the solute. When you're mixing with chemical, then the solute is the chemical, is a liquid. When you're mixing some gas with the gas, then the solute and solvent both are gases. So if you are mixing oxygen with the air, oxygen, you are putting the oxygen, measuring the oxygen from 100% to breathable quantity like 90%, 70%, 60%. So that is the solute is whatever we are using to make dilution or dissolving. That is the solute. The solute and solvent. Solvent is the diluent or where we are putting the original substance to make a solution. Solution means which is the final end product. So making up a solution usually involves two main parts. The substance that's being dissolved, that is the solution, solute, and the substance into which the solute is being dissolved, that is the solvent. In working with solution, it is necessary to know or be able to measure the relative amounts, because you have to know what percentage or what concentration solution you are making. So relative amounts of substance in solution. So you have to know how much solute you have to use and how much you have to put the solute in how much solvent to make a required concentration of the solution. So what is concentration? Concentration is the amount of substance relative to the amounts of the other substance in the solution. What is that? It's the solvent. So say for example, you are using, I just give the examples. You are making the sodium chloride solution. So here, what concentration is going to 5%, 100%, 1 gram, 2 gram, 1 gram per 5 ml, 2 gram per 100 ml. So is the you have to know the concentration, what amount you need, the basic one, the solute, and then that one, how much solvent you need to make that solution of that strength or concentration you require for. So there are different formulas for that. Do that one. You already learned some of that. So relate different concentration of solution that contain the same amount of solute or basic relationship ratio is used. What is the formula? The volume of a solution is V1 times the concentration of that solution. C1 equals the volume of the second solution times the concentration of the second solution, that is the C2. If any of the values are known, you can determine the fourth. The relationship shows that when a solution is diluted, the volume is increased as the concentration. Obviously, when you are diluting a solution, that means you are decreasing the concentration, right? At the same time, volume is increasing because volume increases additional more solvent. So volume is increasing and the concentration is decreased. So these questions comes. When a solution is diluted, what happens? The volume is increased, or they can give the concentration is decreased. The total substance or solute remains unchanged. If you put the 5 gram in 100 ml, is 5%. If you dilute it more, total amount will be 5 gram of the sodium chloride or the solute. But if you increase the volume from 100 to 200 ml, what is going to be? A concentration is going to be decreased. But what the amount you have put at the beginning, it was 5. So 5 gram in 100 ml is going to give you 5%, say for example. So if you add on that same solution 900 ml more water, what is going to be the total volume?
So can you repeat again?
You made a solution, it's going to 5% sodium chloride. Means you have 5 gram of sodium chloride in 100 ml. That solution you have, right? You already made it. That is the concentration is 5 gram %, right? So 5 gram in 100 ml, you have that solution. 100 ml of 5% sodium chloride. Is that clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Okay.
ma'am.
Okay. Now we have that 100 ml of that 5% sodium chloride solution. Now you are adding on the top of 100 ml, you are adding 900 ml of distilled water. So what is the final volume now?
So it's 45.
If you add 900 ml over 100 ml, how it comes to 45?
Oh, it's 1,000.
It's 1000. So
And
1000 ml, right?
yeah.
0.5.
So yeah, your final concentration is 0.5.
0.5, yeah.
0.5
Yes.
gram %, because
Yeah.
you have diluted it to 10-fold, right?
To 1,000.
Yes.
Yes.
Yeah. So it's 10-fold. So you have diluted it. So it's from 5 to it became to 0.5% now. But the amount of sodium chloride is 5 gram. It was 5 gram in 100 ml. That time it was 5% gram %. When that 5 gram is 1000 ml, same amount of sodium chloride, but the strength has been decreased. Strength is now 0.5%.
You're right.
Is that clear?
Yes.
Everyone is clear?
Yes, ma'am.
Very
Yes.
important.
Yes, ma'am.
Very important to understand
Yes.
this.
Yeah.
So here
Yes.
you increase the volume. Is that right? For
Yes.
making it more diluted, you increase the volume from 100 to 1000, right? ml.
Yes,
And
ma'am.
what happened? The concentration decreased from 5 gram % to 0.5 as you added more diluent or the solvent. Think whether what I'm telling is right or wrong, and it goes in your head.
Yes, ma'am. It's correct.
Correct?
Yeah.
Yeah.
Because the volume has increased and the concentration will be decreased.
Exactly. Exactly. So I give you the simple one so that you can understand just the 10-fold. So say for example, they giving lab has a 500 ml of 2% stock solution. Stock solution means the solution what we can make it and keep it, and from where we can make the working solution. Stock solution we make it because it stay for a long time. The diluted one you have to use it every day. So that is called the stock solution. If you have a stock solution of 2% and how much volume you have, that 500 ml. How much? 1.6% can be made using all 500 ml. So you have to make the total 500 ml of 2% stock solution to final 1.6%. So what is going to be the formula? So you know C1 is the concentration, whatever you have, 2. How much? You have 500 ml. And what you have to make? 1.6%. So you need to know how much volume you have to do it. How much you have to add more to make it 1.6%. So if you calculate that, V2 is equal to, you have to divide this one whole thing, that means by 1.6. Is that right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everybody
That's
can understand this simple solution, simple problem. So what is coming? 625 ml is the V2. That is the final volume, V2. V2 is going to be the final volume. So tell me, you have 500 ml solution. Now, how much dilution or solvent you have to add to make a final concentration of 1.6%? You know the final volume for 1.6% will be 625 ml. So how much diluent you have to add over 500 ml to make this final concentration of 1.6%?
So we're going to minus from 625 minus 500
Yes.
equals 125.
Yes. So your basic total amount was 500 ml. Now your
Yes.
final volume you have to reach 625 ml. So how much you have to add it to in the 500 ml of 2% to make the 1.6? You already did the calculation. So our
Yeah.
final volume is V2 is going to be this one. So now from here you know how much volume of the diluent you have to add to this 500 ml so that the 2% stock solution can be 1.6%.
Right.
So they are going to give you different types of this type of question, and you have to formulate out how much you have to do. So get clear idea about the C1, V1, C2, V2, or W1, V1, W2, V2. So when it's this is the concentration, that's why it's telling the C1 concentration. When is the W1 is come, wait, then this is W1, V1, W2, V2. It depends upon, say for you are using, I am telling you to make 8.85% of sodium chloride. Percent means 100. Always, they are not going to tell you 100 ml. So you have to consider 0.85% means you have 0.85 times 100 is equal to, I tell you, to make 1000 ml. So you doesn't know the strength here, how much you have to make volume. Okay. So 1000, and you have to make it calculate like that. Proportion and ratios. You already know 9:1 anticoagulant to blood ratio for sodium citrate tubes, right? Blood to ratio, sodium citrate. And sodium citrate, anticoagulant to blood is 1:9. So what is the ratio means? Proportion are used to determine, quantify from a given ratio. What is the proportion? And ratio is an amount of something compared to amount of something else. So ratios always describe the relative amount, 9:1. And at least two values are always involved. That is, you have to compare 9:1. In setting up ratio and proportion problems, the two ratios being compared must be written in the same order, and they must be in the same units. It's not one is going to millimole and one is going to gram. It is millimole to millimole, gram to gram, kilogram to kilogram. So dilution ratio versus dilution factor. So dilution ratio and dilution factors, probably she already teach you this, right? Ratio and dilution factors related terms, but they are not the same. These are interchangeable items. Sorry. Did she already teach you about this one? I think she did. She told me. Hello.
Yes,
Am I?
we learned it.
Yes, you did.
Yeah,
Yes,
yes, ma'am, the dilution factor.
factors and
So should I
dilution
need to
ratio.
repeat? You already learned that one, right? So how to do the dilution ratio? You already learned that one. Do you want me to repeat it or no?
I'm okay.
Okay. Everyone give me an answer, please.
Half, ma'am.
Miss,
Yes.
can you please go through it? She vaguely go through it. She did not go through like by detail. So can you please go through it, Miss? Thank you.
Okay. So when the dilution ratio is the ratio of the solute to solvent, One is solute, one is solvent. Okay. So if it is a 1:8, the first number 1 is the solute, means sodium chloride or anything, whatever you are dissolving into another 1. And second number is the number of the volumes of solvent liquid. What is the liquid? So it's going to be 8 ml, say for example 8 ml. So you have to put 1 gram in 8 ml. That is 1:8 ratio, if that is the required concentration. So dilution ratio is volumes of solute proportion to volume of solvent. Say, for example, a dilution ratio of 1:5. What that means? That means it has 1 volume of solute and 5 volumes of solvent for a total of 6 volumes of finished product. So total volume is 6. So your adding ratio is 1 and 1. Each how much is present there? That is the ratio. In a 6 ml solution, 1:5. That 1 is solute and 5 is the diluent or solvent or anything. So that is the ratio. Each part's amount is the ratio. When there is 9:1 ratio in the sodium citrate tube, what that means? 9 ml of blood and 1 ml of sodium citrate solution. So that's why our tube is 5 ml, right? 5 ml. So you can see there is 0.5 ml of your diluent and you can add 4.5 ml of blood. So that is 9:1 ratio. Is that right? Did you understand that, what I told you?
Yes, ma'am.
Everybody clears?
5, yeah.
Yes, Miss.
Everyone. I am just
Yes,
hearing
ma'am.
couple of people's voice.
Yes,
ma'am.
Yes, ma'am.
Yes.
Yes.
It's clear.
So you understand the ratio, right? So whatever is that, each part is designated the exact amount. So the total things you have to add 1 plus 5 is get the 6 ml. Okay, so 1 volume of solute is combined with the 5 volumes of solvent for a total 6 volumes of finished diluted product. This is used to describe the simple dilution. So describe the ratio of the volume of the solute of the total final volume enter diluted portion. They can give you different things. They can give you the volume. The solute is 1 and total volume is 6. What is going to be the other ratio? So you have to know total volume of 6 means if there is one volume 1, there another is going to be 5. If they give you 5 and ratio, you have to determine is from total volume is going to be 1. If it is 5, 1. You understand what you mean? What I mean? So they are sometimes they can give you this one and ask you to measure the total volume or the total quantity, or they will give you the total quantity and 1 unit of the ratio, and you have to calculate or you have to understand what is the other unit of the ratio. So it is a simple ratio, means individual unit or the parts which is going to make together to a total volume. Keep this in mind clear, because there will be other things, ratio, factor, the lot of things, okay? So dilution factors is the volumes of the solute and the volumes of the entire solution. Here you used the solute and solvent, and here you are using liquid to liquid dilution factor, and this is dilution ratio. Dilution ratio when is solid versus liquid, that is the dilution ratio. Dilution factor when you are using the volumes to volumes. So describe the, say for example, you have hydrochloric acid and you have to dilute it. So that is volume to volume. So that is the dilution factor. So describe the ratio of the volume of solute. Here the solute is in the terms of liquid, in the volume of the total to the final volume of the entire diluted solution. The formula is going to be the same. 1:5 is going to be 1 part of the hydrochloric acid, 5 parts of the dilute is going to be total of 6 ml. It's going to be the same. Only the changes in the material, whether it's the liquid or is the gas or is the solid. So can also be written at 2 numbers separated by a colon or with a slash. Pay attention to the wording of the question. If there is a dilution factor of 1:5, then first number represent the number of volumes of the solute liquid. That's why it's selling solid liquid. That's why it's a volume, because solute is a liquid here. And the second number represent the number of volumes of the entire solution. So here is telling number represents the number of the volumes of the entire solution. If it is 10, that means 10, and this is going to be then 10. Okay, so number of the represent the number of volumes of the entire solution. That is the solution means the final product, not the solvent. So dilution factor example, what is this telling? 1:5 means that 1 volume solute is combined with the 1:5, the 4 volumes of the solvent to make a total of 5 volumes. Okay, here is the difference. When you are doing the ratio, is going to be, ratio is 1:5 when solute to solvent. So it's going to be 1 and 5. 1 part of solute for the solid one, but 5 parts of the diluent. Okay, so it's not going to be the 6 ml. It's not exactly say the 6 volumes of finish. It's not right. So it may be whatever the volume is going to come. But for the dilution, it's going to be, if you have the dilution, you have to. So 1 to 5 means the total final is 5 volume. Okay, so dilution factor, the final volume is going to be 5. So how much you have to add? You have to add 1 ml and 4 ml to make it a 5 ml. That is the dilution factor. So thus 20% of 1/5 volume of the entire solution consists of the solute and the rest is solute, 20%. So how you are going to calculate? So if it is 1 ml plus 4 ml. So 1/5 volume of the entire solution. Diluting specimens necessary if the concentration is too high for the analyzer to measure. Dilution factor 1/4 is the dilution. Then 4th is the dilution factor. How much you are going to dilute it? 4th. So you are going to 1 dilution factor, not the dilution ratio. So you are going to add 1 ml of that one and 3 ml of the dilution or the solvent or the diluent to make it total 1:4 dilution. Use of dilution factor can be used to calculate the actual concentration of a dilution. For example, serum is diluted to 1/4 and retested on the analyzer. The result is 2.5 millimole per liter. That is the result. It has been diluted, serum First, the serum, we had taken it and we diluted to 1/4, right? Because otherwise it's maybe giving very high value, it's out of the range. So they have diluted the serum to 1/4. And what the result is showing, this is, I'm telling you, this is going to come in question. This result is showing 2.5 millimole per liter. So when you are giving the result to the physician, are you going to give this result, 2.5 millimole per liter? Is that true? No, because you have already diluted the serum to 1/4. So before giving the result, you have to multiply the 2.5 millimole per liter by 4 because that is the dilution factor to get the actual result. So 2.5 millimole per liter times 10 is equal to actual result. What is going to be given to the physician is 10 millimole per liter. That is what is resulted to the physician. Got it?
Yes, ma'am.
These questions may come. They are going to give you this one and maybe ask you to calculate what is going to be. This is going to be the example. They may give you different things, but they are going to give serum or plasma is dilated to 1/6. And you got the result, 1.5 millimole per liter. So what is going to be the actual result, or what result you are going to send to the physician? So what you have to do, if the plasma is diluted to 1/6, 1/6, write it down, 1/6. And the result is giving 1.6 millimole per liter. The sodium value is giving 1.6 millimole per liter. So what is the actual concentration or the actual result? What you are going to do?
Sorry, miss. Can you repeat that, please? Sorry.
Plasma is diluted 1/6. And the diluted result, test result in the analyzer give you the sodium concentration 1.5 millimole per liter. What is the actual result you have to give it to the physician? Actual value.
9, ma'am. 9 millimole per liter.
How you read that?
The 1.5 has here undiluted to 1/6. Diluted.
Yeah, so how you did that 1.6?
So the 1.5 result will be times 6.
Okay.
The dilution that was used.
Okay, okay. So you got it. I don't know everybody got it or not.
Yeah, me too, 9.
Everybody got it? If the questions comes, see, there is no test 1 and test 2. There is only one final test. Now from each module, there is no test 1 and test 2 basically. You can recover or anything. Only one final test.
Okay.
So
Okay,
try to get it everything.
will only be one test?
Yes. So
Perfect.
try to. Why?
I hate it. I hate math. I just want one test and that's it.
That's good for you guys.
Kara.
Then you are happy, right? One test is done.
Yeah, that's.
Yes, ma'am. So the four maths, we have the 4. I heard we have the 4 test.
Yes.
It's 1 or 4. You just said 1, right?
Only one test.
Yeah, we thought that we have 4 tests, ma'am.
For
Yes,
math?
in the D2L, mom, there's 4.
Oh, really? I didn't check it. Okay, let me see. Okay,
No,
I'll check.
Mom. Look.
No, miss, just keep the 1. Just focus on the 1.
Just the one.
Just
Never
the
mind
one.
D2L.
Exactly.
Yes, mom, you can make it as 1.
This is a lot of torture, mom.
Okay, let me see that one. Whether I am wrong or something.
I have to go over this to really get it.
Let me see. Really, no, I don't know that. So I have to. Whatever I thought is going to be only one test. Okay, let me see.
Yes, mom, it's true. 1 test.
It's 1 test.
Okay.
Don't worry about D2L. Sometimes D2L is wrong. So let's focus on 1 test.
Yeah.
But we have to go.
But we have to.
No, but we have to go through the. Oh no, we have 4 tests. 1, 2, 3. Oh my God, 1, 2, 3, and 4. Four
ma'am.
test.
Test
Yeah,
for-
four test. Okay. Okay.
Oh
So,
my
oh my
goodness.
God, how we are going to do that with the 2 weeks, four test, final exam? I don't know.
What's a lot?
So you are already ready for test one. So we are doing that reagent test
miss.
preparation. So tomorrow you can do that unit 1 and 2.
No, miss, I'm not ready.
So how you
Yeah,
are going to
sorry,
do the
ma'am.
fourth test? My
We
goodness.
didn't know about 4 tests. We only know about 1.
I didn't know that. I didn't tell you. I thought that it's only one test. Oh my God.
Ooh.
Ooh.
Yes, I'm not ready for this yet.
So
Yeah,
let
me
me know
too.
when you're going to do that test, dear. So just let me know. We have to figure it out when you have to do the test, right?
Yes, ma'am.
Yes, ma'am.
We don't
Yeah,
have a
ma'am,
choice.
yeah.
It's for
Can I take back my question, mom? You just said one, please.
Okay, listen, I have to follow the D2L. I cannot do anything, right? Oh my God. I didn't know even. Thank you for reminding me that there are so many tests. I thought it's only one test. My goodness. Why they need 4 tests? 2 tests is fine.
I don't
So
know.
you have to, so please, you practice whatever I gave it to you with all of other references, okay? So try to practice as much as possible for the math.
Yes, ma'am.
What is a passing grade?
70% for everything.
Oh Lord.
I'll be happy to have the 70%.
Ma'am, also, are we allowed to bring a calculator with us?
Yes.
Yeah, that too, ma'am.
No, when for the final test, you can only bring the calculator. Yes, that you can do. Only the
During,
calculator. The
like
final
during the
test.
test, we can bring
And
a
yeah,
calculator, right?
yeah. And also other tests you can do in home or online. So yeah, final test I have to be on the campus.
Okay, ma'am.
I'm going to organize all of them. It's short time. How many days have they have this one? Oh my God.
Miss, are we in class next week, all week, or just
No. What do you want to do? You come to the
Wednesday,
class in the
Thursday,
whole week?
Friday? Wednesday, Thursday, Friday, we're in class?
Listen, what you want to be on the lab whole week, or you want to be Monday and Tuesday in online, and then you can do that. Because I have to have the exam. 2 exams I have to take from you guys already.
I think I'd rather have like Monday and Tuesday from home because I thought we were from home. So
That's
we made
right.
Yes,
Yeah.
ma'am.
Yeah.
Wednesday in the lab.
Wednesday in the lab. Yeah.
So we can do it all from home.
Yes, as in it.
I honestly don't mind it either.
Let me see. QA and math is only 1 week or 2 week. So it's 2 week. Okay, so we have another week. Okay. So you have started this week or last week? This week we have started the math, right?
Yes, ma'am.
Yeah,
We are supposed to start from April 26, but due to the things, we are okay. We left skills, so yeah.
Oh Lord.
Game 10. Oh Lord, no Lord. Okay. Okay. My goodness.
Yeah, my
Oh,
goodness. That's all right. You know.
I am getting really so where I'm studying.
I have a 1 o'clock appointment today, miss. So
Where we are now? Okay, so we did this one. So dilution we already did. Dilution 1 plus 9 is equal to 10. So total 1 part of serum and 9 parts of diluent is a total volume of 10 parts. So dilution is ratio is going to be the almost same. So
Ma'am,
here
we
is
cannot see your screen.
oh, I'm sorry. See. I am just screen. You can see now. So basically, so it's same thing, dilution ratio versus dilution factor is same. So when you are doing this one, dilution take, say, example, dilution, a patient serum specimen with saline. You have to do 1:10 dilution. That means the total volume, 1:10 dilution, the total volume is going to end it up with the 10 ml. So how much you have to take to make a 1:10 dilution of a serum? So you have to take 1 ml of patient serum and 9 ml of the diluent, right? The final
Yes, ma'am.
dilution is 10.
Yes.
Final dilution is 10. So that means you have to take 1:9 is going to give you the 10. So 1 part of serum and 9 part of diluent is going to total volume of 10.
The
Okay?
total volume.
Is that right?
Yes,
Yes,
miss.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
If I tell you 3 ml of patient serum to dilute is to 10%. So what you are going to do? 3:10. How much you have to make it? 10 times diluted, 3 ml. What is going to be the
Three.
total volume here?
10. You
Now,
said.
3
No, what did you
ml.
say?
Here we are taking the 1 ml of the patient's. Okay?
Okay.
Mhm.
1:10. You have to dilute the 3 ml in the ratio 1:10. So how much you have to take? 3
7.
ml serum. No,
7.
no,
7.
no, 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 no.
No.
3 ml. 3 ml serum you are diluting to the ratio of 1:10.
30.
So
Yes,
it's 30.
yes. 3:30. Okay, 3:30. So how much? So now is the total dilution is 30. So how much
Oh, yeah.
diluent you have to use now?
27.
27. 30 minus 3,
Yeah.
right?
Yes.
Is
Yes.
that clear?
Yeah,
Yes,
clear,
ma'am.
miss.
So that's why the question is going to come like that.
Oh, Lord.
Oh, Lord. So that's why I'm giving you all the example. It's going to just showing you 1:9, but the question is going to come in a different way.
And
Mhm.
we maybe need to do this on the board.
Yeah.
You go, guys, and do it in the board, in the class. That's why I told you, you're going to come on the Monday and do it in the board. What is you going to want? You guys can do practice, talk each other, group discussion, and make sense. What is the final concentration? Original concentration. DF is designated as a dilution factor. So used when has been dilution and DF is giving or can easily be figured it out. How you are going to do that? FC is the final concentration, OC is the original concentration, and DF is the dilution factor or original concentration is equal to. If you know this one, you can change it. Original concentration is final concentration into dilution factor. That is the FC OC by DF. Okay. So FC, if it is 8 molar divided by 4 is equal to, so this is the original concentration. Okay, you have given this one. And the dilution factor was 4. So what is the final concentration? Is going to be T molar because you are diluting it 4 times, right?
Yeah.
So you are dividing it. So that is the formula. Serial dilution, widely distributed in the lab when a very dilute solution is required, especially when you are doing the culture, bacterial culture, to sort out what type of bacteria is there. So a series of sequentially more diluted solution is required, is go by 1/10, by 1/100, but it's a serially. So you are taking the solution number 1, the original one, you diluted the next tube, maybe 1:10. From this 1/10 dilution, like you are going to the next tube to make it another 10. So it's from the original is going to be 1:100. So that is called the serial dilution, and you can go lot until the you need it. So serial dilution example, start with your stock solution or the known concentration. Line up additional tubes and add a constant volume to each diluent. Say for example, you are want to 1 ml of saline, put 1 ml saline to each tube except the first, the concentrated one. So move the required volume of a solute over the stock solution to the first tube. Say example of 1 ml of the stock and you are adding is to 1 ml of the diluent. So 1 ml of diluent is already you in the second tube. First, the original one. In the second tube, you have 1 ml of diluent, and you are transferring 1 ml from the stock solution. It's a serum or plasma or blood cells, whatever may be, you are transferring in the second tube. So what is the dilution now? 1:1, right? 1:2. Total volume is become the total volume 2, and dilution is 1:2. So stock solution. Then from this 1:2, you are taking another 1 ml from this one. What is the now diluted one? And you transfer into the third tube, which is another 1 ml. So it's going to dilute it to 1 is to double dilution again. So 1:4. So that's why you are diluting it. Okay. So move 1 ml from the 1:2 solution over the next tube. You may have now diluted the stock solution 1:4. Mix well and continue down the line. See the picture, next slide. Stock solution. This is, you have 1 ml of the saline, 1 ml of saline everywhere. And then you are adding 1 ml from your stock solution. So it's getting half diluted because half of your saline and half of your stock solution, you mix it. Okay. So from here, you are transferring 1 ml again to the next tube. What is that? One is 1 ml and you are adding another from the diluted one, right? So it's going to dilute it 1/4. Same thing, you go far, you can go to the maximum dilution. So the last tube is left as the final concentrate of this example is 1:128. So this is generally used for determining the bacterial culture to specifically rule out any specific bacteria in the microbiology. Dilution factor calculation exercise. If you are asked to make a 1000 ml, that's why I told you 1000 ml of 1:10 glacial acid solution using distilled water diluent, what is going to happen? 1:10. You have to make total 1000 ml. So total volume is 1000 ml, right? Total volume is 1000 ml. So what is going to be the dilution now? How much you are going to take glacial acetic acid and how much you are going to take the diluent?
It's 100 acid.
100 acid and?
And 1000.
No.
In 900 ml.
900
ml.
Total volume is 1000 ml.
Yeah, 100 and 900.
Yeah.
Plus 900.
So if you just divide 100 by 900, it's going to say 1:10. Factor is same. So when you are taking 100 ml of glacial acetic acid and 900, so it's going to give you the same 1:9. The 1 part of glacial acetic acid and 9 ml of 9 parts of the diluent. So parts. So it's going to be, you have to add 1 ml or 100 ml of glacial acetic acid and 900 ml of diluent or water, distilled water as a diluent to make a 1000 ml of 1:10 glacial acid solution. Okay. So what are the standard solution? What are the blank solutions? Standard solution is one that contains a known or exact amount of the substance being measured. You know, say for example, 5% of glucose. So you know I put 5% means 5 gram of glucose in 100 ml of diluent or solvent. So that is the standard solution. What from where you are going to use standard solution? What is the known concentration? You know how much exactly is in the solution. That is the standard solution. And working standards, these are prepared from the stock solution. So you are going to take from the stock solution, you are going to dilute it, or you are going to use for your working standards as per your need. Standards used in spectrophotometry. Blank solution is blank solution contains only the reagents used in the procedure, but it doesn't contain the substance to be measured. So if you are using the glucose, say for example, you are doing an assay, in that solution there is no blank solution. You have to use the blank solution to make a, so that the other in the solution you are making, there may be something else. Say for so there is no additional thinking is picking up from any solution preparation. We are telling this one. Sometimes the buffers and other things are made up from different compositions, so that any of the ingredients is not in the buffer is not giving any readings or additional reading or reducing reading. So you have to use the blank solution, except the content we are measuring. Say for example, you are measuring the sodium. So in the black solution, it can use the buffer, something which doesn't have any sodium. You can use the phosphate buffer. So that is not going to interfere or additional reading for the sodium from the blank solution. So blank solution contains all the reagents used in the procedure, but it doesn't contain the substance to be measured. Is that okay? Understandable? When I make a solution of concentration from scratch, depending it is solid, liquid, you are meaning percent volume by volume. When you are making from liquid to liquid is volume by volume. When you are making from weight to volume, sodium using solute by weight and volume with the liquid. Volume by volume, when I use the liquid solute and diluent as a volume. Weight by weight, when I'm mixing two solid solutes or two gases, so that is the weight by weight. What do percent volume by volume, weight by weight, and weight by volume mean? Percent volume concentration of solid is expressed by percent volume by volume, which stands for volume per volume, used when both chemicals in the solution are liquids. Say for example, any acid, any oils, or anything, when you are mixing with one with another, solute is in the liquid form, because that solution, that solute you have to measure it in the volume, because you cannot weigh it. So volume by volume. Solute is you are measuring the volume, and diluent is also in the volume. So that is called the percent volume by volume. And weight of the concentration of solution expressed at percent of weight by weight, which stands for weight per weight, where each chemical is disregarded and only weight is used. When you are using, say for example, you are using sodium chloride with potassium chloride, you have to mix it. Both are solid. So that is that time you have to weigh the percentage in weight versus weight. And then weight by volume. Sorry. Sorry. So weight by volume is mass concentration solution. As I told you, weight by volume. Say solute is going to be the solid chemical when it's dissolving in a liquid solvent. So percent volume, ml of solute per 100 ml of solution. That is the percentage. Any percentage means is terms of 100 ml or 100 gram or anything. So example, 0.5 ml of HCl per 100 ml solution. What is the concentration is going to be?
0.5%.
Yes. So X times 100 is equal to 5 by 100. 5.100. What did it? 5%. So 5 by 100. 5% means 500. It's going to be 5 because it's in 100 ml. See?
Yes. Yeah.
5 ml per 100 ml. That means it's 5%.
Yes, ma'am.
Right? So that's why they said 100 ml times X into 5% means 5 times 100. We need 100 ml of solution X. So X is equal to 500 by 500 is equal to 5%, volume by volume. So weight by, again, try to calculate. Sodium hypochlorite would be measured for 500 ml, 10%, volume by volume solution. You measure for 500 ml of 10%. So you need 10% of 500 ml, right? So you doesn't know the X percent. You need the 10%. is equal to XML divided by 5 ml. So 10% means 10 by 100. Okay? And you doesn't know how much you have to take from the 500 ml. So XML divided by 500 ml. So it has been divided, ultimately calculated 50 ml solution of hypochlorite. You need to add the 500 ml with distilled water. So 50 ml of sodium chloride plus 450 ml of distilled water is going to give you 500 ml of 10% volume by volume solution of sodium hypochlorite. You got it?
Yes, ma'am.
Okay. The same thing, weight by weight. So it's going to be the same thing. You are going to use example weight by solute, 100 gram of solution. Everything is percentage, means 100. Solute mass 25 gram, solvent mass 100 gram. The solvent is 100 gram of solution, means is 100 gram of solvent mass also. Solvent is also in the solute state. So 1 ml of distilled water weighs 1 gram. Okay. So therefore solution mass plus 125 mass of sodium chloride in this solution is 25 divided by 125 x by 100. So its mass is 20% only. So 25 in 100 is 20%. 1 gram of solute in 100 ml solution. So 1 gram sodium chloride is to make up total volume 100 ml. So you have to add 1 gram of sodium chloride is said 1% by volume. So if you need to do isotonic saline, so 1% volume by saline has been made. So what you are going to 1 gram of sodium chloride used to make a total volume of 100 ml. Okay, so make sure you are not adding, you are weighing 100 gram of sodium chloride. You are putting in a beaker or volumetric flask as we shown before how to do the reagent preparation, right? And then you have to make 100 ml of total. Are you going to add 100 ml of water here directly?
Like
how you are going
making
to make it? How you are going to make it? 1% of sodium chloride?
we measure first the sodium chloride.
Mm-hmm.
And then we add 99 ml of water.
Better 90.
Something solution.
Yeah.
90.
Oh, 90. Yes, ma'am.
90.
90.
Then?
100 and minus.
No, then what you are going to do? Then what you are going to do after adding that one? First, you have to weigh the 1 gram of sodium chloride. Then you have to transfer in the volumetric flask with the funnel. Then you have to add the distilled water slowly. It's going to be 3/4 full. So after 3/4 full is 75 ml or 80 ml. Then you are going to stir it, swirl it until it got dissolved. Then we dissolve. Then you're going to add slowly. How much rest water? You are the volumetric flask. Are you in theory you are going to add 100 ml water?
No.
No.
Total 100 ml including the sodium chloride of 1 gram.
Yes. Because we're preparing 1%.
So it's not that 1 gram of sodium chloride, then I'm adding 100 ml of water. No, it's going to be more volume. Because even it's solid, it has some volume. When it dissolves in the 100 ml of water, it may give you 110, 105 ml. So concentration is going to be disturbed. So it's going to be total volume of 100 ml. For making any solution that is the rule. Is the total volume. Okay? So example 2, isotonic saline or physiosolic saline is 0.9%, right? So 0.9% aqueous solution of NaCl. What you are going to do? How you are going to make it? If I tell you to make 0.9% of physiological saline, what you are going to do? Tell me. .9% of physiological saline or 0.9% saline. This is very common and you have to know it. Point 0.9% is very easy. Solute is sodium chloride and diluent is water.
It's nice 3. Water. Add a nice 3 water.
What? I can't hear you properly. How much sodium chloride you have to take?
Sorry, ma'am, can you repeat the question, please?
0.9% sodium chloride solution in water, distilled water.
0.9 in distilled water.
0.9% in distilled water.
1 9.
What is percent means?
100.
So 0.9% means how much?
0.9.
Of what?
9 over
9.
0.9 of what?
Of the diluted
No,
water.
0.9 of diluted water. How you are going to get the diluted water from 0.9? 0.9 is the volume or weight or what?
0.9 is
Solutes or whatever.
It's the
There is
result.
no whatever. What is 0.9? Is the diluent or the sodium chloride is dilute?
The diluted.
What is the diluted? Why you are getting this dilution here? 0.9 ml or gram? What you are talking about? 0.9
gram, ma'am.
gram.
0.9
Gram is diluent. Gram is not diluent. It's a solute. It's a solute. So 0.9 gram of sodium chloride. That is a solute. So how you are going to make 0.9%?
You make that percentage, you find the percentage of it.
Percentage, you get the percentage of 0.9 and then times 100 to get the 0.9.
Any percentage means that amount. Keep it in mind, that amount in total 100 ml. That amount in total 100 ml. Total 100 ml. Again, that amount 20 gram in 20 gram percent means 20 gram in total volume of 100 ml. So 0.9% means 0.9 gram in the total volume of 100 ml of diluent. So you have to add 0.9 gram of sodium chloride and then you have to add water up to 75 or 80 ml. You have to start and you have to make it the total 100 ml. That I just discussed a little bit before. Is that clear now? Isotonic solution is 0.9% aqueous solution of NaCl. So 0.9% salines means 0.9 gram of sodium chloride is diluted to a total volume of 100 ml of distilled water, where sodium chloride is the solute and distilled water is the solvent. There's another example for weight by volume calculation activity. So if they say solution has a 7.5 gram of NaCl diluted to 100 ml with water. So what is the percentage? 7.5 gram. Straightforward, 7.5 gram in 100 ml means 7.5%. But how you are going to calculate it? So you doesn't know what percentage, right? X percent. That means 7.5 gram in 100 ml of solution. So you have to cross multiply X percent means X by 100 and 7.5 in 100 ml, 7.5 by 100. So if you cross both hundreds, it's going to be 7.5. So this is the formula. In general, it's very straightforward. Any amount in 100 ml, any amount, whether it's the liquid or it's a solute or anything gas in 100 ml, is the percent. So how you are going to calculate it? If it's a diluted with 200 ml, so it is going to be 200. So 7.5 divided by 200. So it's going to be more diluted one. 7.5 in 200 ml is going to be 3.75. Because if it is 200, so its value is going to be 200. So it said sodium chloride diluted to 100 ml. So 7.5 gram is diluted to 100 ml. Instead of 100 ml, if I say 200 ml, so you have to put the 200 ml here. But the X percentage you doesn't know. They are asking you to what is the percentage. Percentage means always 100. So how you are going to calculate is X percentage divided by 100 in 7.5 by 200. If I say is 200 ml. You have to know the formula, then you can calculate. Okay? So you guys have to tell me tomorrow when you are going to take 2 exams, test 1 and test 2. You can do it in the same day if you want. Or you can do one and then we can do some class. Again, the next day you can do another and do the class, okay? So it's 103. I don't like to list too much complicated property, you guys. So tomorrow you are going to go from 30
sounds better.
glassware requirements for reagent preparation. So that is where we are going to go. Here's the video. Molarity, more complex. Molarity. Oh my God. What they are going to do with all these things. There is no need of all these things. Why they are doing this? My goodness. Whoo. Okay. So we are going to do from here tomorrow. Remember, 30 from slide number 30, you are going to start tomorrow, okay?
Okay, ma'am. Thank you.
Okay.
Okay, ma'am.
Okay. Bye-bye. Try to practice as much as you can. Practice is very important. You can see in the math. So then you can understand what you are doing.
Yeah.
Okay. Yeah.
Okay, ma'am.
Okay. Bye-bye.
Yeah.
Bye, Mom. Thank you.
Bye, ma'am. Thank you.
Okay.